Good evening, everyone. A very warm welcome to all the dignitaries, respected speakers, faculty members, and participants who have joined us today on this virtual platform. I am truly delighted to host the inaugural ceremony of the AICTE Training and Learning Academy sponsored 6-day faculty development program on deep learning for computer vision, organized by the Department of Computer Science and Engineering, Tripura Institute of Technology, Narsingar, Tripura. This FDP aims to enrich participants with the concepts and applications of deep learning techniques in the field of computer vision, what is one of the most dynamic areas in today's technological world. We are proud to share that this FDP has received an overwhelming responses with a total of 313 participants from across the country. Participants have joined us from various states like Andhra Pradesh, Tripura, Tamil Nadu, Maharashtra, Haryana, Telangana, Madhya Pradesh, Gujarat, Karnataka, West Bengal, Puducherry, Uttar Pradesh, Kerala, Orissa, Bihar, Delhi, Punjab, Rajasthan, Uttarakhand, and from other different states. Such a diverse participation truly reflects the academic enthusiasm and nationwide reach of this activity. We are extremely thankful to AICTE and the ATAL Academy for their support and approval, and to all our eminent speakers for being a part of this academic initiative. Now, to formally begin the inaugural session, I would like to invite Dr. Ankur Bishwas, Associate Professor and Head of the Department of Computer Science and Engineering and convener of this program, to deliver the welcome address. Sir, please.
Thank you, madam. Am I clearly audible, ma'am?
Yes, sir.
Good afternoon good evening to all distinguished speakers, chief guest of the program, Professor Sanjay Kumar Shah sir from Jadavpur University, principal sir from TIT, faculty colleagues, and dear participants. As the head of the department, Computer Science and Engineering, Tripura Institute of Technology, it is my pleasure to welcome you to this very special AICTE ATAL sponsored 6 days faculty development program on deep learning for computer vision. It is truly wonderful to see so many enthusiastic learners and educators gathered here for this FDP. And we have total 313 participants from almost all the states of our country. I extend warm greetings to everyone joining us for this insightful journey into one of the most transformative areas of modern computing. I hope you will agree that we are living in an exciting era where artificial intelligence is transforming nearly every aspect of our lives. Computer vision, in particular, is helping machines understand and interpret the world just like humans do. From self-driving cars to medical imaging and smart surveillance, the possibilities with deep learning are endless. Through this faculty development program, we aim to explore these possibilities together, diving into both the fundamentals and the latest advancements in this dynamic field. Over the past decade, the field of computer vision has undergone a remarkable transformation, mostly due to advances in deep learning technologies. Traditional computer vision methods relied heavily on handcrafted features and algorithms for image processing and analysis. But the emergence of deep learning has enabled extraordinary levels of accuracy and automation in visual recognition and understanding. Computer vision and deep learning share a close and mutually reinforcing relationship. Deep learning, particularly through neural networks such as CNNs, has significantly advanced the capabilities of computer vision, enabling machines to automatically learn patterns, features, and representation directly from raw image data rather than relying on manual feature extraction. As a result, tasks such as image classification, object detection, facial recognition, and scene understanding have become not only more accurate but also more adaptable to complex real world scenarios, making deep learning an essential drivers behind the recent breakthroughs and widespread adoption of computer vision technologies. In the upcoming sessions, we'll have the privilege of learning from eminent subject experts and researchers who have worked at the forefront of AI. They will share their knowledge and experience on topics ranging from neural networks, image processing, object detection to real-time applications in healthcare, automation system, and smart cities. So I request all participants to engage actively, share your thoughts, ask questions, and make the most of this collaborative experience. And also think about how we can bring these concepts into our teaching, our labs, or even inspire our students to take up research in this transformative field. I would also like to express my heartfelt gratitude to AICTE and the ATAL Academy for their constant support in promoting quality faculty development programs and nurturing an ecosystem of continuous learning. Special thanks to our coordinator, Professor Gautam Palsar, and the organizing team of the department for their efforts in making the program possible. So once again, I welcome you all and wish you a rewarding and inspiring faculty development program ahead. Thank you.
Thank you so much, sir, for your warm and motivating words. Next, I would like to invite our respected principal, Professor Vijay Kumar Upadhyay, Tripura Institute of Technology, to address the gathering. Dear participants, there might be a slight delay as we are facing some minor technical issues from our research person side. We request you all to kindly bear with us for a minute or two. Thank you for your patience and understanding. We will begin the session.
Am I audible?
Yes, sir.
Thank you. Uh, Good evening, everyone present virtually in the inaugural session of the Faculty Development Program being organized by Computer Science and Engineering Department of Tripura Institute of Technology. The topic of Faculty Development Program is Deep Learning for Computer Vision. Now, first of all, I would like to welcome Professor Sanjay Kumar Saha, Professor, Computer Science and Engineering Department, Jadavpur University, for accepting our invitation to grace this special occasion as chief guest among his busy schedule. Respected head of the Department of Computer Science and Engineering Department of our institute, all participants across the country, and my dear colleagues present over here, coordinator of this faculty development program. On behalf of Tripura Institute of Technology, I welcome you all in this inaugural session of the faculty development program on deep learning for computer vision. So we are also thankful to AICTE for giving us the opportunity to host this sort of faculty development program, which I am sure our colleagues across the country, researchers, faculty members, will be enormously benefited, and the magnitude of responses, interest that are shown, that reflects the importance of the topic and the quality of the program AICTE and ATAL Academy has established by this time. So it has become a ATAL FDP has become a brand name for quality learning and exchange through the interaction from various field experts, researchers, industry professional, which provide a very good platform for the research activities to take forward. And I extend my sincere appreciation to the Department of Computer Science and Engineering of our institute and the coordinators for conceptualizing and organizing this highly relevant faculty development program. The topic chosen is indeed contemporary and aligns with the rapid evolution of artificial intelligence, particularly in the field of deep learning and computer vision, which is revolutionizing the various fields from autonomous vehicles and medical diagnostics to surveillance, robotics, agriculture, etc., etc. Now, let me take this opportunity to introduce our institute to our learned participants. That Tripura Institute of Technology, which was formerly known as a Polytechnic Institute, started its journey in the year 1958 with 3 diploma engineering programs. In the year 1997, fourth program in electronics and communications has been started, and in 2007, this institute was upgraded to a degree level full-fledged engineering college. Thereafter, new campus has been set up, and the progress has reached then accreditation by NBA about the UG programs has been received. We have implemented TechIP 2 and TechIP 3 projects, which have really helped the institution and the faculty members. And as a result, we were in a position to start MTech programs, PG programs in 4 disciplines. So presently, the institute is having all 3 sorts of program: PG in 4 branches, then 5 undergraduate program, and 8 diploma engineering program. So if you happen to come to the state of Tripura, please pay a visit to our institution. We will be very happy to host you, and also we would also looking for academic networking with your institution so that this this platform can provide us another dimension, and together with mutual interest, it may be in research, it may be in faculty development program, or other similar type of academic endeavors, we can help each other and we can improve our visibility, so that in all respect, especially the most important beneficiary, that is our students, get benefited. And during this process, we as an academician, faculty members, we will also get opportunity to learn from each other. I also like to thank for all the resource person who will be delivering their expert lecture in coming 6 days, right from today, for their time and effort and benefiting our participants by sharing their expertise. With these few words, I would once again like to welcome everyone present in this virtual inaugural session, and especially to our chief guest, Professor Sanjay Kumar Saha, who is also our member in the Board of Governors, and we look forward to meet with him in near future whenever the opportunity comes. Uh, Thank you, everyone.
Thank you, sir, for your constant encouragement and inspiring message. Now, it's my honor to welcome our chief guest, Professor Sanjay Kumar Shah, Professor, Department of Computer Science and Engineering, Jadavpur University, Kolkata, an eminent academician and researcher. Sir, we request you to share your thoughts with us.
Okay, suddenly I cannot hear anything. So am I audible?
Yes, sir. You are audible.
Okay, I think it's now my turn. Okay, respected Professor Vijay Kumar Upadhyay, Principal, Tripura Institute of Technology, Dr. Ankur Vishwas, Associate Professor and HOD of Computer Science and Engineering Department, and also the convener of the program, and Professor Gautam Pal, the coordinator of the FDP program, and my colleagues and other participants. So it's a privilege on my part to become part of this event. And as Professor Upadhyay has mentioned, that the topic itself is very pertinent and it's very crucial and important for all of us, even beyond the computer science and engineering people. It's for all. And that is also evidenced by the participation. This is Pan-India participation. So that way, again, I'm grateful to the organizer. I should like to note it down that it's really very beneficiary for all of us to attend such a program on such a topic at this point of time. I'm taking a little bit backwards. As Professor Upadhyay has mentioned, that the journey of Tripura Institute of Technology started from the Polytechnic. And I also have the opportunity to visit Tripura Institute of Technology. So I have looked into the transformative phase that it is being changed from the Polytechnic to the engineering college, the hurdles that they have experienced and then they have overcome. If I'm not wrong, that Computer Science and Engineering Department is now NBA accredited. And possibly we from Jadavpur University, we were the mentors of TIT at that point of time. Although During that point of time, we were not MBA accredited. Right now, we are also MBA accredited. So anyway, so to some extent, I am also part of the journey that you have gone through. Now, let us come to the point, that is the topic and the experience that we'll be sharing during this 1 week program. That is deep learning for computer vision. So there are two key terms, deep learning and on the other hand, the computer vision. Both are very crucial. So if I go back, so in general, we say AI or artificial intelligence. Basically, that is the mother of all, that is the superset of the whole thing. We say that AI is nothing but in one form. AI can be defined in a number of ways. So in one way, in very generic form, we can say that it is the programs that can sense, that can go for reasoning, it can adapt to the scenario, and finally it can act also. So it will be sensing, so it will be getting the, collecting the data, it will be dealing with the data, it will look into the data, analyze it for reasoning, and then the changed scenario, it will try to adapt, and finally it will have to act also. Or in other way, in more simpler form, we can say that it is nothing but the certain theory or computer systems that is able to perform tasks normally that require human cognition and intelligence. So we are trying to automate the things as if to mimic the human cognition and the intelligence. So if I go through some salient aspects, the journey that it has come from AI to now today's DL, generative AI and all those things. So then there was the development of the machine learning that we say that is nothing but again a subset of AI. So machine learning, when we are talking about this, more the programs that it gets exposed to more amount of data, its performance that will further improve. So it gives the machine learning, that paradigm, it gives the computers the ability to learn without being explicitly programmed. So getting the data, getting the observations, from those observations, it will try to learn the things. Now again, we can go for those classifications, supervised learning, that is we have the data and we have the level, so we have going by those examples, we try to understand the patterns. There may be unsupervised learning, whenever we say talk about clustering kind of thing, as if there is no level, based on certain patterns, certain similarity, we want to group them. So that is the unsupervised kind of learning, and there may be reinforced learning. That is from our outcome, say algorithm that has given some outcome, we have taken some in real life also as human being. We take some decision, we take some action. What is the outcome? Based on the outcome, we try to modify our learning, our experience. We reinforce our learning. So same thing in machine learning also, we can have one kind of scenario, that is the reinforced learning. So supervised, unsupervised, reinforced learning. So maybe that during the 6 years, this program will come across this kind of terms. And then there is a jump. During last 1 or 2 decades, we are talking about the deep learning or so. So deep learning, we can say this is a subset of machine learning, whereas the machine learning is a subset of AI. So whenever we say that AI, basically we mean everything. Now again, this deep learning, so more amount of data, as Professor Ankur Vishwas has rightly pointed out, that in case of a machine learning kind of thing, as I have said, we have some descriptions of the data, certain features. Say if I take about the image, certain image features or image descriptors, or if it is video, or if it is a text kind of thing, we have certain features, handcrafted features designed by the feature, by the domain experts. They will be designing different features as if those are the descriptors or the vectors or the observations. Now, in case of deep learning, as Professor Vishwas also has mentioned that as if we are having sufficient number of huge volume of data, so now we are moving towards a data-centric kind of environment. More and more data, if we have, we are now richer. That is the things. During my school days, I used to remember geography teacher used to say, a country having more oil, they are rich. Now the thing is that more and more data you are having on a particular problem, on a particular theme, more and more powerful you are. So if we have sufficient huge volume of data from the raw data itself, it will try to understand, it can get those patterns, get those descriptions. So there is no need of those kind of handcrafted feature generation. We can get rid of that. So that is the deep learning kind of thing. Again, the basic deep learning approaches, primarily we can break it into number of, broadly, two kind of things. One is the discriminative model. Say, when we think about the classification kind of thing, let us take the simple kind of situation. Say whether this mail is spam or not spam, or whether this signal is a normal kind of signal, or this is abnormal or anomaly kind of scenario. Or if we go for multi-class, that kind of scenario, whether this data belongs to it represents a cat or dog or something else. So we, based on the data, based on the things, we try to discriminate the things, whether it belongs to this class or it belongs to that class. That is the discriminative model. In most of the cases for the classification kind of problem, basically we talk about discriminative model. So whether it can discriminate or differentiate different type of data, different type of outcomes or different type of scenario or not. That is the essence of the discriminative model. On the other hand, we can have generative model. As if given a set of data, a volume of data, it will try to find out underlying probability distribution of the data so that it can generate that similar or nearly similar kind of data itself. That is the generative model. So it will study the data, it will try to formulate the probability distribution of the data so that it can generate the data itself. That is the generative model. Now, what is the beauty of the generative model? As we have said, more and more data we have, we can go for better kind of things. So if we look into AI, ML, and DL, the requirement of the data, from where it will learn, it will study, it will understand the pattern or whatever it may be, that data requirement gradually increases. Getting that volume of data itself is a problem. Now see, this generative model and subsequently the generative AI, that will try to, address this particular problem. They will be able to generate similar kind of data. It's not that there was no generative model prior to this deep learning. If we think about net-based classifiers or hidden Markov models, basically those are the initial kind of things or examples for studying the probability distribution of the data. So we can say that the concept of generative model started with those things. And now we are coming for generative adversarial network or GAN. So if we take this generative model, so now it has emerged into a huge discipline itself. That is the generative AI. So that is again a subset of deep learning. So AI, ML, deep learning, and subset of deep learning that we now very much will talk about. That is the generative AI that will help us to generate new content. Now, very often this discriminative model and generative model, basically they work together. As I have just uttered, can possibly that will be part of this program also. Generative adversarial network. Now see, there is one, there are two networks. One is the generator, another is the discriminator. Basically, this generator is the generative model. It is producing something. It is generating something. Now, the adversarial, basically, what does it mean? That we want to place one against another. As I've mentioned, there is one generator following the generative model. There is another discriminator coming from the discriminative model. Whatever we have generated, whether this is a real one in my database or this is a fake one, a generated one, discriminator tries to challenge that one. It tries to understand. It will discriminate between the real and fake. Now here the approach is very fine. In GAN network, that whatever I generate, discriminator will try to check whether this is a generated one, fake one, or this is the real one. Now, getting from this feedback, the generator tries to improve itself so that it can make the discriminator full, so that the discriminator will not be able to identify that this is not the actual thing, this is actually the generated thing. So that is the basic essence of the generative adversarial network. Now, we may think that, if we look into these, whatever I have said, there is a basic philosophy of the thing. Now, if we look into the algorithm parts, we are more conversant with those stuffs. If we look into some of the algorithms in, say, machine learning, say, linear regression, that is the foundation of machine learning, or in general, regression. Then support vector machine, decision tree, random forest, or clustering techniques. These are nothing but we mentioned that those are nothing but the machine learning algorithms. If we come for the deep learning, when there were certain hurdles mathematically resolved, computational power increased, the problems of, say, vanishing gradient, issue of overfitting, underfitting, those were resolved, then the deep learning took a huge turn, and basically we came out of those convolutional neural network, CNN, and recurrent neural network, RNN. Basically, if we want to, say, if I think of image, there is no temporal aspect. There is no time series involved in that. But if I think about, say, audio data, there is a time sequence. If I think about a text, a sentence, in a sentence, there is a noun, pronoun, verb, adverb, adjective, etc. There is a sequence. If we miss the sequence, if we cannot remember, if we don't have the memory kind of thing, we cannot deal with those. Or if we think about the video, that is also a time series kind of thing. So whenever there was the issue of the time series kind of thing, we want to analyze the time series data, a sequence of data. Then there was the advent of these recurrent neural network kind of algorithm. Again, memory, to what extent, how much, that is a problem. So there was a development of LSTM, long short-term memory. And basically, using this LSTM, gradually there was other models, and finally we landed to today's large language model. Although that started with the, for NLP kind of natural language processing kind of thing. But now the usage is not limited to only those natural language kind of thing. So CNN, RNN, LSTM, LLM, and generative AI algorithms, those are now the, part of the DL algorithms. If we think about this GPT, so that is also nothing but the part of the generative AI. And there was advent of some other models, say diffusion model. Basically, if we have some input, we try to diffuse some noises. That is one pass. Then ultimately, after adding subsequent noises, ultimately from the input, say if I consider input image, it is converted into the noise. Now, in the backward pass, from this noise, whether it can get back to that original input image or not. So once this is learned, then see from the very scratch, given some arbit kind of noise, it can generate that particular type of images. So that is the essence of diffusion model, and diffusion model is also very much part of this generative AI. Now the issue is that, as we have said, the deep learning models, they require huge amount of data. Now, how to deal with these kind of things? So one issue I have said that using the generative AI, we can automatically generate a similar kind of data to augment our data kind of things. Still, there will be, somebody may say that I'll have to train such a huge networks. Say earlier in machine learning, maybe that for the image classification, we'll be computing some shape feature, color feature, texture features, that kind of thing that will be given to the network. So now in the neural network, we know that weight and input vector, they will be multiplied, etc. Some optimization, gradient descent, those kind of things will come up, back propagation, etc., etc. Through that, it will learn the weights of those feature vectors. Or if I have multi-layer perceptron, number of those parameters, that will also increase. Now, in case of a deep learning kind of thing, when these features are also being learned from the raw data itself, whole image is now given as the input. From there, through CNN or some other kind of things, it will learn. Now, whenever it will be learning, so obviously number of parameters, say if I consider, say my image size is 1024 into 1024, from every pixel it is taking the data. In one layer, there are number of nodes, and again these number of weights. So it's billions of parameters. Now learning these billions of parameters, that will obviously require huge amount of data. So if I need to generate the data using those generative AI, that is also computationally very costly. Now we have the foundation models or pre-trained networks. Those are already trained on huge volume of data by the computationally rich set of groups. I mean, forget about the institutes like Stanford and all those things. No, Google and other organizations, they are much more powerful than these MIT and Stanford and all other things. So they have provided us the foundation model, which are nothing but the pre-trained network. So we can use those foundation model. We can go for fine-tuning as per my requirement with a small amount of data. So the weights are already learned. So we can now work with the foundation model. So one aspect is that I hope as a part of this FDP, we will go through, see, hurriedly I have just mentioned the things. I'm not an expert of all these things. I am also a beginner. I am also a learner. So I know the pain. So basically, this is one aspect that we'll have to understand what deep learning or in general AI has to offer to address our problem. That is one aspect. And in the computer vision, we can find out, say, based on this deep learning kind of thing, we have autoencoder is one kind of, network. Basically, it is nothing but consisting of encoder-decoder combination. As if I give some input image, that will be encoded into lower dimensional latent space. And the decoder from that lower dimensional space, it will try to get back to the original one. So this is unsupervised kind of learning. So basically, we have given some input data that will be encoded into low dimensional feature space, we say latent space, and the decoder will try to generate the original data from that latent space. And to the way it will be trained, so to what extent it can emulate, it can get back the original data. So that is the thing. See, very nicely we can use this one for anomaly detection. Say there are, in deep learning kind of thing, we can have lots of problems that data we may have. We need all types of data. Say if it is a classification problem, data for all the classes, they may not be balanced. Say if we think about a fraud kind of scenario, cases of fraud is very less. Now, if we try to address, if we try to apply various kind of undersampling, oversampling kind of thing, still data imbalance is an issue. But see, if my goal is to find out the anomaly, what we can think? We can train my autoencoder only with the normal kind of data. Now, decoder will reconstruct the original thing. So what is the reconstruction error? So if we train the data based on the normal kind of scenario, that will be well trained. Now, if I give some abnormal data, that time likely the reconstruction error will be more because it was not trained for that. So that way, see, the autoencoder can be used for various purposes. It can be used for even dimensional reduction. It can be used for denoising of the images. It can be used for learning the features as we are going for latent space, lower dimensional, and it can be used for generative model also. The decoder, it won't be generating exactly whatever was the input. It will be close to that one, but not exactly the same one. So from that, conceptually, autoencoder can be used for used as a generative model also. There are different variants of autoencoder kind of thing. There is another, this encoder decoder kind of network widely used, particularly in the domain of biomedical image segmentation, that is the UNET. But there is a, I mean, philosophically, there is a difference between the autoencoder and UNET. So possibly, I hope UNET will also be covered in some lecture. There we'll see that it's not only that it is being encoded and decoded. Between the encoder and decoder part, there is a connection that gives the actual thing also. That we say skip connection kind of thing. So anyway, this UNET is very much, I mean, it has become the de facto standard for medical image segmentation. If we think about generative adversarial network, or say, if we have a pair of data, say this is the daytime picture of a particular place, and this is the, say, evening time picture of the particular place. If I have a paired kind of data, now using this paired kind of data set, we can train it so that given the daytime data, daytime image, I can convert this into the evening time image. Now see, we can go for lots of applications. Say if there is a drizzling, raining, little bit of raining is there. So if I have a generative adversarial network which has been trained by the paired images of normal image and the rainy season image. So if it is trained by the pair of data sets like these, it can be used, given the daytime normal day, sunny day image, it can generate the rainy day image, or the vice versa. This has lots of utility. Say, if I have the underwater images, it is, I mean, the image quality will be little bit different. Or if it is not underwater, because if we go by the physics, there will be lots of other kind of effect will come up. It's not that if I take the image of an object in the, say, in the normal, in my room, and if it is underwater, if I capture the image with that, they won't be same. So if I want to improve that, one, that underwater image, so that we can make better decision-making process for the, say, vessels, say marine vessels, then I can use GAN also for improving that one. Or say, if I have a hazy image and the clear image, so I mean, in a foggy weather, we can have a hazy image. So in the vehicle, I want to see that what is the normal kind of scenario for that particular area, so that I can make that decision. So we can use this GAN. Now, one pertinent issue is that always these paired kind of images may not be available. Then how to resolve that one? Then there is a cycle GAN. Basically, two GANs are being used, as if from, say, image from X, I'm going to Y, then Y again, I'm going to X. So there will be two GANs side by side. That is the cycle GAN. So that can resolve the issue that I don't require the paired images. That is the proper image and the corresponding pair, the corrupted image. I may not have that thing also. So cycle GAN can be used for, even that can be used for denoising, that can be used for improvement, or that can be used for, say, style transfer. Say, I want to change the, given a Picasso style picture, I want to convert this into a Van Gogh style. So style transfer I can use, I can remove the seasonal effect, haze to dehaze, that kind of thing, painting to printing, printing to painting. So these kind of things, day, night, or high resolution to say low resolution to high resolution imaging, particularly say in medical domain, high resolution imaging, that devices will be very costly. But if I have properly trained a GAN network or a cycle GAN kind of thing, I can go for this high resolution to low resolution to high resolution, that kind of thing we can go for. Diffusion model that we have talked about, that also can be used for, say, cross modality generation of the image. Say, in say cancer study, say normally the biopsy and that kind of histopathological study that is done at a very initial stage, or all kind of getting all kind of omics data. Say suppose I have the biopsy report, the histopathological kind of thing, but I don't have the genomics or gene expression kind of thing. Now, yes, I'll close in 2 minutes. So that also can be utilized, so that from one form of genomics, I can using the diffusion model, I can simulate other kind of genomics, and jointly we can go for the decision making. So see, if we look into conventional image problems, image processing problems, be it image enhancement, be it say segmentation, normally for a particular computer vision problem, we consider these as the pre-processing. Now it's not only in the computer vision problem that I want to go for summarizing a particular video, or I want to do some other kind of analysis, not only for those things, even for the pre-processing part also. Initial stage of, deep learning, normally the pre-processing were still under the control of the domain expert. Now see, those also with the advent of these modern models and networks, we can even include those pre-processing in a single pipeline. So it has given us immense opportunity, even the requirement of huge volume of data that also can be surmounted with the help of generative AI. And it's worth to go through all these techniques, and if possible to understand the mathematical part of this particular deep learning, that linear algebra and say vector calculus, all those things, and the optimization techniques. So that will give us the proper insight, so that it's not only will be using the networks developed by others, we can also contribute, or we can also go for tweaking the networks to fulfill our requirement. So in that sense, I feel that the particular topic, see, it's not in general deep learning, it is keeping a particular application area, a vast area in mind, computer vision. It's really a good platform to get the initial ideas, and even if we don't follow or don't understand all the things, but initiation that we are starting a new journey in this orientation, so in a guided manner that will unfold gradually. So that will be worth, I think. And once again, I thank to the organizer for inviting me in this particular program, and also choosing this pertinent topic, a demanding topic. And I also expect that the participants will enjoy these 7 days or 6 days, to be specifically 6 days journey. So thanks to all.
Thank you, sir, for your insightful and inspiring words. To conclude today's inaugural session, I would now like to invite Mr. Gautam Pal, Assistant Professor, Department of Computer Science and Engineering, and Coordinator of this FDP, to deliver the vote of thanks.
Hello, am I audible?
Yes, sir.
Okay. Good evening to everyone present in this AICTE Training and Learning ATAL Academy sponsored online faculty development program. It is my honor and privilege to propose the vote of thanks. I extend my sincere gratitude to the chief guest of the event, Professor Sanjay Kumar Saha sir, Professor, Department of Computer Science and Engineering, Jalpur University, Kolkata, for sparing his valuable time and delivering his valuable speech in this inaugural session of this online faculty development program. I would like to thank our principal sir, Professor Vijay Kumar Upadhyay, for his continuous support to make this event successful. I would take this opportunity to express my gratitude to all the resource persons from academia and industry. I would like to thank each and every one of the organizing team, our HOD Dr. Ankur Bishwas sir, Dean Academics, faculty members, staff members and students of TIT. I want to thank all participants from across the country for participating in this week-long FDP on deep learning for computer vision. Last but not the least, I would like to thank AICT Training and Learning ATAL Academy for giving us the opportunity to organize week-long online FDP on deep learning for computer vision. I would like to thank one and all once again for joining this FDP. Wishing you all a great learning experience ahead. Thanking you all.
Thank you, sir. With that, we come to the end of the inaugural ceremony of our 6-day faculty development program on deep learning for computer vision. Thank you all for your gracious presence. We look forward to a fruitful and enriching week ahead. Again, thank you to all our dignitaries and guests for gracing the inaugural session with their valuable presence and inspiring words. Now, moving ahead, we begin with the first technical session of this AICT ATAL sponsored 6-day faculty development program on deep learning for computer vision. The session 1 is scheduled about deep learning and computer vision and overview. We are truly honored to have with us Professor Vipin Gupta, Director of UNET Solutions, Moga, Punjab, as today's expert speaker. Mr. Gupta is an industry professional with over 30 years of rich experience in the field of computer vision, artificial intelligence, and machine learning. Before we invite him to deliver talk, let me take a moment to share a brief biography of our distinguished speaker. Vipin Gupta is BE, Red Hat Certified Security Specialist, Red Hat Certified Engineer, Certified Ethical Hacker, Cisco Certified, Microsoft Certified. He is running his own company, UNET Solutions, with presence in Punjab. The company has got tie-ups with various other companies and organizations for offering consultancy, open source based solutions, high-end training to faculty and industry professionals. He has got more than 30 years of experience in IT related fields. His specialization is in networking, security, cloud computing, SDN, Docker, Kubernetes. During his long career, he has been associated with various universities, engineering colleges, polytechnics, private institutes, and corporate sector. He is interacting with both corporate and academic world. He is author of 4 books. Out of those, 2 is Linux, 1 SDN, 1 Kubernetes, and also created 19 online courses on Udemy. More than 20,000 and 100 students from over 100 countries on Udemy platform to top companies are offering many of his courses to their employees. He has conducted hundreds of workshops, STCs on various technologies. He has also published 20 papers in international conferences and journals. Sir, please proceed.
Thank you, Arpita, for the nice introduction. Am I audible?
Yes, sir.
Oh, thank you. So I'm sharing the screen. I think already I'm just left with 1 hour session. So I'm sharing the full screen. I'm a more of a practical person, so I will be giving small demos, 7 to 10 different demos to make you understand what is deep learning and computer vision. I will not go into the technical details because for that, lot of other sessions are there. So my purpose will be to make aware what is deep learning, what are their application, and how it is integrating with your computer vision. So a lot of diagrams are there. Uh, uh, when we talk about computer vision, the best place to visit is an eye hospital because they make the use of computer vision there in great sense. So I will be discussing for 5 minutes how they are using in eye hospital this type of thing. Then what are the other thing in which we use that deep learning and computer vision? So first of all, the main applications. Other hundreds of other applications are also there, but I'm just specifying certain, and I will be giving the example, demos of most of these applications which I'm showing here. The first thing is when we are using the computer vision and deep learning, what we want to classify whether it is a dog, whether it is a cat. That means image classification. It could be anything. It is not that we always give the example of dog and cat, but it could be anything. So we want to image classification is one application. Then what we want object detection. Suppose like in this diagram we are showing that cars are there, pedestrian, lot of buildings are there. So what we want to identify multiple objects, and what we want to identify by drawing the objects. So I will be giving the demo of this also, which of the machine learning or the deep learning technology or the computer vision libraries we are going to use for this. Then image segmentation is there, like Dr. Sir was talking about that mean in medical profession they are using this image segmentation because if you are want to identify certain diseases like tumor, that type of thing, that what one we want exact locations of these each and every pixel. That mean in this case object detection, what we were doing, we were just drawing the square. But in the case of image segmentation, we would like to draw the exact boundary. That means these type of thing. That means if each and every pixel that which belongs to that particular object, we want to segment that type of thing. Then image and style, that means we want to create a new type of images and that type of thing, in which again we will be showing that which type of models they are using. So when we talk about when we are combining the computer vision and deep learning, that means what is basically computer vision? We are enabling the machines to interpret and understand the visual world. Like in our case, what we do in the case of human eye is by using our eye, we are able to identify all these things. But in the case of computers, because when we talk about computer, they do not see these images. They only see pixel, that type of things. So in this case, the computer vision gives you the same type of you can say power which the eyes gives to the human. So that means they help in understanding the visual world. And what is the purpose of deep learning? Already we know that it is a subfield of machine learning. It has revolutionized the computer vision by automatically learning hierarchical feature from raw pixel, replacing the need for manual feature learning. Like suppose I have fed millions of dog images and cat images to our deep learning model. Now what it is going to do, it will identify certain features. We will be looking at how they are going to identify. Then after they have identified the different features, then the model will be able to predict the thing. That means if I'm going to show them the new image, what they are going to do,
they are going to detect that type of things. Let me start with a little bit of these applications because I've already told that I'm a little bit of a demo type person. So in my case, whatever demos I will be using, I will be sharing the links of those. Some of these demos are online links available. So there is one docs cloud.google.com vision, the software is there. So a link is there. So when I'm going to click this, what I can do, I can upload certain image. So in my case, what I'm going to do, I will put certain image there. So in my case, I have got certain sample images are there. So these samples are there. So in my case, what I will do, I will put this image. Suppose I'm putting this vehicle image there. That means I have uploaded the image. Now we want to see what this is going. First of all, I have to specify whether I am a robot or not, because sometimes certain person, they misuse this type of facility. That means you have to just go to docs.cloud.google.com, vision, docs, drag and drop. Now what it is saying? It is showing that certain license plate is there. Then it is showing because with a scooter some car was there, so it is also showing that tires are there. Then it is showing wheels are there, that type of things. And then when we talk about text, it is exactly what is the make of this scooter. It is able to identify, and it is correctly able to identify the license plate also. Then other properties are there, which is colored dominant colors are there. Then it is also detecting whether this is a spoof image or that whether it is showing some adult, that type of thing or not. That means it is able to identify. That means whatever they are using behind the scene, it has been trained. So let me again put another file there. So I will again use some image. So in my case, let me put one photo there. So I'm just going to upload some photo. So again, it depends upon the internet speed. So it can take 30 to 40 seconds. So again, what we are doing, we are trying to feed. Already that deep learning model is there behind the scene. This, they have given us the front end. So what it is going to do, it will analyze the image and look at this. It is identifying the face. Those, like in our case, we tell that what it is going to do. It is going to place boxes around the objects. So here also it is putting the boxes. Joy, sorrow, what it is showing, what is the object. So different things it is showing. Object is person, glasses are there, it is showing. Jacket is there, outwear is there. Then labels different, and then it is showing you the probability also, whether with how much certain this model is there. So again, these type of things are there. That means this model is able to detect these type of thing. Let me give another example. For that, I have to just close my camera because I will be using another application. I will be using another application. So I'm just closing my camera. I'm just closing my camera. Then I will go to another site. And this site is, that means different small demos I'm giving to make you understand. Then I will show also one code I will be showing. Now again, this is one link is there, teachable machine with Google. Again, I will be sharing this link. And here, what I have done, I have captured certain images. So what I'm saying, I'm using one option here where I'm specifying open project from file. So I will say open project from file. Which type of project? A lot of type projects are there, like image project is there, by which it can detect whether it is a dog, whether it is a cat, or whether it is a tiger. Then audio is there, whether certain noise is there, it will be able to detect. And then there is a pose project is also there, in which it can detect different type of movements, like when you're raising the hand, or if you're other type of motion, it will be able to capture. But in my case, I will show you the example of this. So in my case, I will be clicking on this. So what I will do, open an existing project from a file. So in my case, I have got one project available with me. So this is one project. So now what is happening? In this project, I have captured two images, two different type of images. In one, I have captured 25 images of the tiger, and I have captured 28 images of dog. Now what I have to do? I have to train this model. And when you are training the model, different options are there. How many epochs, what will be the learning rate, these type of things you can specify. Now, what it will do? After some times, what it will say? It will say that model is trained. Now, what I am going to do? Now, I want to predict. Now, this is, now tiger is there. Now, look at this. What it is showing? It is showing that tiger is there. Now, when I'm saying, in my case, I have got one dog is there. So now what it's showing? It is showing dog is there. That means it is correctly able to classify. That means we captured certain samples. Then what we did? We trained the model. And then what we did? We tried to predict. Again, this was able to do. Then that is the example of your image classification. I will close this one also. I will close this one also. So again, I will move back to, I will again power on this, my camera. So this was another example. Now let me again move to this. That means we have shown this one. That means instead of dog and cat, tiger, and that we were able to identify dog. Then objects were there. Now we have already discussed about this. Now when we talk about basically DL, so the DL is basically a subset of ML, and ML is a subset of AI. Sometimes we need to understand. I have seen a lot of people, even after years in this field, they are not correctly able to identify whether this is a deep learning application or machine learning application or artificial intelligence application. So in my case, what I have done, I have implemented all the three different type of applications, and it will hardly take, I will just run one command. And when I'm going to run one command, with one command, all the three applications will be running. Those AI application, also ML application, and DL. When we will be running those application, and when we will be analyzing the result, you will be clearly able to understand what is DL, what is ML, and what is AI. Now, let me give you one example. Suppose I'm saying that today some person from Ludhiana has won 1 crore lottery. Now we know that Ludhiana is in Punjab. So what I can say? I can change the statement. I can say that someone from Punjab has won 1 crore lottery. Since Punjab is in India, so I can also specify that today in someone from India, they have won 1 crore lottery. That means, again, this DL, I'm talking about Ludhiana, it is a part of Punjab, that is ML, and that is part of your India, that is AI. Why I'm talking about? Because in my case, I will be giving you lot of small demos on AWS cloud. And when we go to the AWS cloud, what do they say? They do not distinguish between the AI or ML or DL application. They have put all the different 15 to 20 different applications under the heading machine learning. That means in those application, one application is image recognition. Although they have put in this machine learning, But basically, this is a deep learning application, and we will be looking at different of things. So my purpose of saying is that when we talk about that, mean if I'm talking about certain DL application, because it is part of machine learning, that belongs to machine learning also. And if I'm talking about machine learning application, it is part of that artificial intelligence. But in my case, I want to distinguish all these type of things. So when we talk about artificial intelligence, what is the method? How we try to put the intelligence in this? So AI is basically a broad field of computer science dedicated to building intelligent machines capable of performing tasks that typically requires human intelligence. This includes reasoning, learning, problem solving, perception, language understanding, and AI can be rule based. Suppose I have written one rule that means if somebody is going to do, please do this. Like a game of chess playing computer, Deep Blue. What they have done, they have put all the different logic. If somebody is moved, the very complex rule engine they have created. So when we play against these type of computers, normally that computers is going to be, because lot of calculation behind the scene it is performing. That means it is rule based. But since ML and DL, if we are going to create some application in ML and DL, that will be learning based. So AI could be of type A type, rule based, and learning based. So in my case, I will give a small demo. I have created certain 3 to 4 rules, and we will see how it behaves. And what are the different AI applications are there? Siri, Alexa, Google Assistant, they all are AI based application. This chess playing computer, again, AI example. Then we have got robotics is there. Then again, because robotic is designed to perform specific tasks in factory, like assembling car, it uses AI principle. It perceives it in environment by sensors. Then we have got, sometimes AI can be used for the recommendation purpose also, although not recommended. Suppose I just want to say to my AI system, if a user buy a product A, please always recommend the product B also. Here we are not learning anything. We are just hard-coded the route. So it could be, but normally we do not use this type of. Then we have got this machine learning is there. Is a subset of AI that focuses on enabling system to learn from the data without being accelerated. So in my case, what I will be doing in the application that I have created, we are just going to take 2 minutes to run that application. Participant, please mute the mic because it creates the disturbance. So in this case, ML, what we do, we train the data. The data is mostly labeled data. So from that data, what we do, we try to learn the pattern. So in my case, I will be giving one small example of iris data set. That means we have learned certain parameters from the data set, and then when we are going to pass certain parameters to our machine learning application, we will see whether it is able to detect which type of iris is this. So we will be discussing that. Now, what are the different applications? Email spam detection. Now, when we talk about Google Mail, it has got one of the best spam detection mechanism is there. So it is used for that purpose. Product recommendation. Now, I'm a big fan of Korean serials. So whenever I open Netflix, it always show me half of the recommendation they are of Korean serial. That means recommendation system. Again, when you visit Amazon, they show you certain products which are based on what you are searching or what is your past behavior. According to that, it will see. So for recommendation purpose. Then fraud detection, like financial company, your bank could also use. If it is finding that always I am doing the transaction from North India side, and suddenly they are finding that from West Bengal certain transactions are happening, so they can flag that type of transactions. Then predictive maintenance in factories. That means by looking at certain behaviors of those devices, what we can predict whether it is going to have some issue or not. For that purpose, we use this predictive maintenance. Then deep learning. Now, what happens in deep learning? In this case, in machine learning, what we are going to do, if I've got, suppose 1 lakh images are there of a dog and cat and dog. So I will be having those labeled images of a cat and dog. Then we will give that to our machine learning algorithm that will detect those type of thing. But in the case of deep learning, we give the unstructured data. That means the images we will be giving, the scale of data will be very large. If there are 1 lakh images in the case of my ML, then in the case of ML, it will be millions of images. And those will be, most of those images will be unlabeled type of things. That means we will supply millions of cat images and we will supply millions of dog images. Now, deep learning model by by using a CNN network, that type of things, by using this input function output and then certain hidden layers, what it will be able to do, it will be able to extract the feature. In the machine learning, we have to, by ourselves, we have to detect the features. But in the case of DL, that algorithms, those mechanisms, they will detect those features. And then when we have detected certain features, we will supply certain few labeled images also, so that, because if it is only the unlabeled type of images, then that will not be able to identify whether it is dog and cat. But most of the learning will be on unlabeled type of images, but we will be giving certain labeled data also, so that it is able to relate that with, and it will be able to find whether it is dog and cat and dog, that type of things. So in this case, multiple stages will be there. So what are the applications? Facial recognition, I will be giving the demo of that also. Then in self driving cars also. Then speech recognition, because these days different languages are there, then different accents are there, and certain similar sounding words are there. So behind the even speech recognition system, behind the scene, they use quite a deep learning. So if it will be possible, I will be giving the example of this also. Then medical image analysis. Last week, I was visiting one very big hospital, which is in Punjab, and I had a meeting with their team of doctors. And I was just asking how you are using it in your field. So they are saying that quite a lot is happening in our field. That means we are also using these other things. And I will be showing the images also, which type of machine they are using, for what purpose they are using. For analysis purpose, they are using this type of thing. Then generative AI, that means these models, and they are behind the scene, they are using deep learning type of thing. So before moving it, and when you have to distinguish between what is ML, DL, and AL, you can always think of a Russian doll, nesting doll, in which in big doll, one smaller doll is there, in smaller doll, further dolls are there. Now, to make you understand, let me give you one example. So in my case, I will be giving one example of AI and then we will see how that is going to learn. So in my case, I've created 3 applications: AI application, DL application, ML application. And what technology I am using today, I am not going to discuss those, and which technology I am using for deploying these applications, because in your case, you might be using Kaggle, or you might be using Google Colab, but I do not use those type of things. I use DevOps principle, that type of thing. So last day I am having another session. So there I will be using showing you exactly what I'm doing. So in my case, what I have done, I've got one virtual machine is available, in which I have got Ubuntu 24.04 Linux is installed, and it is having this IP address is this, because sometimes if we have to access the application, we need to know the IP address. So in my case, the IP address is this 192.168, 142, and 130. because I will be giving 3 to 4 different demos. So in most of the demo, when I will be assessing the front end, I will be using this address. And then I have got one folder is there, AML, ML, in which all the demos are there. So let me just show you. And one tree command is there, which will show you that I have got, all are in Python. Then certain requirements, certain libraries, it is going to automatically load. So in my case, I'm just going to run one command. That means there are certain methods available by using which what you can do. By just running one single command, you can deploy all the 3 applications. So in my case, I'm just running one command, docker compose up, and you will be surprised to see how much time it is going to take. Hardly it is going to take 1 minute to deploy all the applications. So in my case, AI application, ML application, and DL application, all the 3 applications got deployed. And so now I want to assess. Now, what is in first, I will show you what is in AI application, then ML, and then DL application, and then you will be able to appreciate. So when I'm moving to this, this application, AI application, so in already we have discussed about AI. AI is basically rule-based. So in this case, what I have written certain rules. But please remember, when we talk about that chess computer Deep Blue, that will be millions of lines of code. But here what we have specified, if somebody is going to say hello or hi, please give the response hello there, how I can help you. If they are putting certain in question certain keyword weather, please respond with I cannot tell you the current weather, but it is always sunny in my world. Then third rule I have written, if there is a buy and milk in question, then please respond with adding milk to shopping list. Is there anything else? And the fourth is if somebody is not going to use any of these, one catch-all is there in which we are going to put the response. I am a simple AI. I can only respond to a few programming sessions. So now let me show you, because it will help you in understanding. So in my case, I will, that means my applications are running. My AI application is running on 5000 port, and the ML application is running on 5001 port, and my DL application is running on 5002 port. So in my case, I will be sending, and please remember, you can, for sending, you can use Firefox browser, Chrome browser, Edge browser. But here for showing you the demo, I'm using one command line browser. So here what I'm saying, I'm typing this thing. I'm asking to the AI certain question. So what I'm saying, curl is one browser. I'm saying, what I'm saying, question is hello, hi, because I have written. Then because in my application is running on, I could have used that address 192.168, that 142.130, because I am putting those query by using the local system. So I'm saying local. So when I'm saying this, what answer it is giving? Answer hello there. How can I help you today? Then I'm just going to put second question. And what was the second question? In second question, we have put, in this way, we have put that, can you help me buy milk? So what is it saying? Adding milk to your shopping list. Is there anything else? Now, third question. I'm just asking certain philosophical question. So again, I will cut paste. So here I'm saying, what is the meaning of life? Have we, I think certain thing is missing. So again, let me, so I will just again cut and paste. So again, when I'm pasting that type of thing. So again, I'm asking such a question. Now, when I'm asking the third one, it is saying I'm a simple AI. I can respond only through the few programming questions. So that was our AI rule-based. It does not learn anything. Whatever we have fed, according to that, it is working. Now let us move to the second application. So in the second application, This is ML application. And if you are going to carefully look, I have just imported the, loaded the RS dataset. And then we certain program, and behind the scene it is using Flask, Skylit, Learn, and NumPy type of. In a lot of sessions are there where they will be discussing these type of technologies in detail. I'm just interested in the front end type of thing because this is an overview, so I will not go into the details now. And plus I'm just now what I'm going to do, I'm just going to question. I will put certain question, because in machine learning we already trained our model. So in my case, I will be supplying certain data. What will be that data? I am specifying that sepal length is this, sepal width is this, petal length, because already I have trained my ML model. It already has knowledge. So what it is going to do? It is predicting. That means in our case, what we did, label data was there. So we trained on that. Now the third case. In third case, we are moving towards this DL application. And here, please remember, we are using the pre-trained deep learning model. Sometimes you might be training the model yourself, that millions of images, but that is very time consuming. Sometimes other people have already trained certain model. Suppose if we want to create one DL application which is mobile based. So what I want that it should be particularly concerned about the resources. It should use a few resources. So we have got one pre-trained model is available, mobile net V from Keras. This is which is used for classifying the image. So again, I'm not discussing the code, but here what I have done, I have imported that you can so, and again I'm using that Flask, TensorFlow, Keras, all these type of things. Then what it is going to do, and these all the things when you are going to attend other session, different people will be using different of these technologies. So in my case also I'm using. Now I want to predict that type of thing. What I want to predict? I want to predict whether that is cat or dog. So in my case, what I will do, in my case, I have got data is there. Let me show you. When I'm running this tree command, you will see that cat and dog is there. So in my case, what I'm doing, I'm going to run this command. Again, this is a classification problem, but in this, that model was trained using deep learning. So now what we are saying, curl, again, I'm saying image, because where I'm running this demo in this directory, and my cat is in diagram is in which directory? It is in data directory. So I'm specifying image at the rate data cat. Then I'm specific, because in my case my DL application is running in 5002 port. So when I'm going to click, now it will use that mobile net v2 model. Then what is it going to do? It will detect which type of whether it is a actual, and you can say which breed this is. So it is going to. Now what it is saying? It is saying it is Egyptian cat. And what is the probability? It is also, that means it is almost 80% sure. Then it is showing certain other cat that it might be this type of, or this might be this type, and it is showing the score. And let me specify that also. Let us talk about it. Then we will see whether my actual, the diagram I have put, whether actually it was a cat or dog. So here also we want to see. So now here I have specified the image of dog. Now what it is saying, that is label, it is predicted this, and with how much certainty? 52%. Then it could be this one and this one. Let me show you. So in my case, what were the actual diagrams? So I'm just opening this one because a lot of things are running in my system. So it is getting a little bit slow. So let me show you certain files. So let me open. I will minimize this. Then I have got this demo is there. And clicking on this, then data is there. In data, if you are going to carefully look, dog is there. And it was saying that golden retriever. And if you are going to carefully see, it has actually predicted that type of thing. And when I'm saying it is cat, then it was detecting that is Egyptian. So that is also running. Now I do not want these applications. So launching application is very easy. So let me power down those applications also, because I have to run other applications also. So now all the three, I'm dismantling all the three applications. We will be discussing which technology I'm using when I will be taking the last session on this. So let us again move to a little bit theoretical, and then we will see certain other examples also. So now, again, I'm moving to the slides. So when we talk about this, how the deep learning, or you can say that CNN, it works. Again, I'm going to give a brief overview, and again 5 to 6 small demos so that you are aware. Now, please remember, for our eyes, it is okay. We are able to distinguish what is tiger, cat. But for this computers, images are just numbers. And it uses this RGB, red, green, blue, that type of things. And it gives the number from 0 to 255, that type of things. But the problem is, when we have to identify, or when we have to do the, or deep learning model, they have to do the feature extraction. First could be, again, this very good on deep learning, very good course is there. So I have taken this from there. So here, viewpoint variation might be there. That means if certain images are in this orientation, certain in this, certain this, so it could cause problem. Then light problem, illumination condition could be there. That means there the conditions are different. Then scale variations could be there. And in the case of cat, deformation, we know that cat can take many shapes, so flexible. Then occlusion mean your object might be hiding behind certain things. Then the background might be different, like in the case of army person, their uniform is sometimes we are not, if we are in jungle, we will not be able to recognize that type of thing. Then interclass variation is there. Now what happens, how these networks, they try to detect first lower level features, then like edges, dark spots, that type of thing, then mid-level features, eye, ears, nose, then high level features they are able to recognize them. Again, I'm I'm quickly trying to explain the things. Then high level, what are the high, like in this house, it is going to recognize that this is a door, these are windows, and these are the stairs. Then in the case of this model, it is going to eyes, nose, and it is going to detect that type of features, multiple. And if it is this vehicle, wheels, and then headlight type of things, and mirror, these type of key identity, that mean deep learning type, they will be able to, by using the hidden layers, could be hundreds of hidden layers. Then again, let me again we will do. Now again, I'm moving towards certain application like facial organization, pose estimations, these type of things, object detection type of things. I will give that my local, you can say, a demo also, but let me take you to the cloud. So in my case, now I have opened AWS cloud. So here we have got one famous service is there, which is known as image recognition. Although when we are, because in the case of AWS, we have got more than 200 different services are there, from quantum computing to security to networking to load balancer to servers to game development. but they have put the AIL, deep learning, or machine learning application all under your category in which they have mentioned machine learning. That means they have not divided that this is AI application or this is DL. So when I'm going to click on this, I will find certain application. Out of that, one application is your image recognition, and it is used by lot of industry people. And what it is mentioning, although it was under the heading machine learning, but what it is saying, deep learning based video analysis service, search, verify, organize millions of images. And now let us look. Now what it is saying, you do not need computer vision or deep learning expertise to take advances. When I was deploying that AI, ML or DL application, I need to have the knowledge. What the cloud do for you, it automatically behind the scene, they have implement everything. You have to just create the front end application. So let me show you which facilities it offers. So first of all, let me go to this label detection. So again, that screenshot was from this. So now what it is trying to do, it is detecting that neighborhood is there. It is showing city also, road is there. Then it is showing you that street is there, urban is there, and certain person is there. That means it is able to detect different of things, because when I was giving you the examples, that mean where we can use. This is one example. Then we have got another diagram is there, in which again what it is showing, it is architecture showing, it is showing 100% sure that is building, it is showing city landscape. And what you can do, you can send your upload your image also. So let me upload. So in my case, let me open this image. And please be careful when using this service. Yesterday I have used this service is only for 10 or 15 minutes. Already a $2 bill is there. So I do not know how much. So what it is able, this is the picture of my house. So what it is able to detect plant. It is able to detect this is car, this is car. Was not able, and it is showing building. That means it is able to detect. That means it is a house, building, that type of things. And what we can do, and the response is in which format? It is in your JSON format. You can whatever response it is giving, you can capture that response, and accordingly you can create other applications, that type of things. That let me go to the image properties. Now in this image, what it is specifying, it is detecting. That means if you have got one particular image is there, we want to see which color, dominant colors are there. So it is going to give you all the information. And if we are going to specify this, now again, it is specifying that in this, that means when we are interested in image property, how much brightness, sharpness or contrast is there. If you want to study about a particular image, then this they have got this image property. And this is very crucial. Now, sometimes we upload adult videos on YouTube or certain videos in which violence is there. Have you wondered how they are able to detect? So they use this type of service, image moderation type of service. So in my case, what I'm going to do, I'm going to upload certain image. So I'm just going to, and I'm not displaying because certain, let this it should be able to. That means this image recognition, it should be able to detect. Now what it is saying, actually in this that photo, yesterday I just clicked photo, I took some toy weapon and I just clicked the image, and now I am supplying that image to the our recognition. It is not that we have to use the cloud. You can use computer vision libraries and other mechanisms. You can create this type of application yourself. What it is saying, in this violence is there and weapon is there. Although I should not show this, but quickly I will. So that was one. So it is showing that a certain weapon is there. So in my case, it is showing what is the request, response. It is that means it is able. And if we are going to, that means when the people are uploading the videos, and it is able to recognize these things from the videos also. Let me show you another, although this is not a adult type of content. So here it will be able to recognize these type of things. So let us detect. So it is analyzing. So it is showing certain animation is there. Then this model is there. So again, it is showing that swimwear is there. So it will show you the certain property, how much sure is this. So this comes under your, this is also one. So I am trying to show that these are all computer vision application, and behind the scene deep learning is working. Then let me give you another example, that is facial analysis. Now what is that mean? It is showing that this is happy, appears to be female, look like a face, age range. It is specifying this is the age, it is smiling, appears to be happy. So it will be able to detect these type of things. Let me upload certain things. In my case, let me go to this, and I will be putting certain, let me put that image. So we are uploading the image, and what we are trying to, participant, please mute the mic. So we are uploading the image. What it is going to do? It will be able to detect that type of thing. So it is uploading, then it will analyze. It is analyzing the image, and certain charges will be there. So please be, when you're using the cloud, you should be aware about this. Now, look like a face, appears to be male, and age range, it is specifying, and it is correct. Not smiling because at that time certain sun was there. So appears to be confused, although it was not, but wearing glasses. So it is giving you, show more, it will show you different. That means it was able to analyze certain things. Then some another feature is there. So for again, what I'm going to do, because this application might be using camera, so I'm just going to close this camera. So I think I am not able to disable. So in my case, it was able to detect these type of thing. Then I'm not doing this face liveness. Sometimes when the people are facing the interviews, what happens? They might be what you can say, manipulating the certain thing. That means instead of they present, they might be showing certain poster or certain live movie they might be playing. Like there was one movie was there, I think, Need for Speed. In that they were playing the video, that type of thing. So here also, if you are going to use this face liveness application, what it is going to do? It will be able to confirm whether actually some live person is sitting there or not. But because certain other services are also using the camera, so there is a chance of hanging my computer. So I'm not using. But let me give you this image. Suppose what the policeman will be having the data of thousands of criminals. And suppose if we have found out from certain street cameras, we have found out that certain photo has been captured. We want to find out which criminal is that type of thing. So this face comparison we can use. So in my case, let me, like in this case, what it is saying, in this case, both are same. Both persons are same. So in my case, what I'm going to do, I will upload one of my photo, and I am just going to upload second of my photo. And please remember, we have seen a few months back, Kumbh Mela was there. There they use advanced these type of computer vision type of things because there were certain mechanism that mean for a certain amount of space, if there was more than 1,000 persons, so they were able to detect that type of thing. And they were also able to detect those things if some criminal or certain bad elements are there, because they were using certain sophisticated computer vision techniques there. And I'm 100% certain that because at the scale which they have deployed behind the scene, what they were doing, they were using cloud computing that ever. They might have used certain other application, but it could be because the facilities that are provided by this service, you can say, imagine recognition. It is a very powerful service. And now we will see what it is going to show. So meanwhile, let me show you certain slides because it might take time a little bit. So in my case, a certain comparison will be there. So it will show. Let me again move to that thing. Again, that means image has been uploaded. Now what it is? Now it is saying that both persons are same. So when we have to compare the faces, it can be used for security purpose and other purpose also. So we can use for that. Then celebrity recognition is there. It is able to detect which person. If I'm going to upload the photo of a certain celebrity, it is going to, but due to copyright issue, I'm not trying to. And in my case, I'm not that much famous. It will not be able to recognize. But if you are going to put certain famous persons, so millions of famous persons are there, so it will be able to detect these all type of things, and it has been able to predict quickly. And what about this? So in my case, what I will do, I will again upload my own. So in my case, what I'm going to do, I will upload this one. So I'm uploading the. So what we want to see, whether it is able to detect these type of things. So again, these all are applications. So now look at what it's saying. This is Innova, and it is saying that this is the number. Although it is number correctly, it is showing a correct number, and make also, and this is, and also hybrid model is there, so it is showing that also. That means it is able to capture that type of things. And then this is one very useful. Suppose under factories, I will take another 3 to 4 minutes, then 5 minutes will be questions. Now sometimes in factory we want certain protective, like during corona we wanted that everybody should be having mask, so it will be able to detect these type of things. So it is able to detect whether that person is having this type of face is there or not. Let me show you another photo. So now what it is able to do, it is able to detect these type of things. That means this person is having this thing. That means this person detected. Then if we will move to this person, it is again saying that face detected, face cover detected. It is showing. That means in factory, if certain regulations are there that you should wear mask, that type of things, you can for fulfilling those requirements, or instead of manually checking each and everything, you can deploy these type of. And then what we can do, store machine analysis. That means if you are going to put certain videos, it will be able to find out what is in this video, which celebrities are there. So again, it will be able to recognize these type of things. Since there is a limitation of time, Imagine offers you hundreds of other services. They have got one poly services there. That means in poly service, let me briefly. Imagine poly is there. So it will turn your text into speech. So in my case, I just wanted to give, like which type of space, and it give you real type of space. So when we are going to say, so it will different voices are there. Then we have got one transcribe service is there. In transcribe service, what happens, whatever, if you say, suppose you people are attending the lecture and you want to note down each and everything what I have said, so you can use their transcribe service. So it will be able to do all type of things there. It will be able to very correctly identify each and everything. So because I think the time is up to 8 o'clock, so different things are there. Then please remember, let me 2 minutes, I will take additional 2 minutes. Then in my case, what I did, one of our family member, what they wanted to have a you can say one wallpaper. So what we did, we used the Canvas AI option, and we created, because when we were first creating, it was showing certain birds. Then I said that I want a certain fish also. Then it added those fish also. Then I said I needed butterflies also. Once I have implemented this, what I did, now then I created that flux. That means generative AI. That means it can generate the images according to your requirements. And then what we have got, certain others, that means these all images, please remember quickly, let me show you. These all images has been generated by different AI software, different deep learning techniques behind the scene. So one stable diffusion is there, which creates a lot of like this type of image, high quality image. This was created by using diffusion. Then we have got I created artificial voice also, these type of things. But again, we have got limitations of time is there. So in my case, now I will leave 5 minutes for the question. Participants, I think next speaker is already ready. Participants.
If participants have any question, so they can ask the questions.
Sir, can I ask, sir?
Yes, sir, please.
Sir, I am Jagdish from Aditya University.
Yes, sir.
Sir, at the beginning of your lecture, you showed one Google Teachable Machine, some kind of
Yes.
the demo. So if
Yes.
I do that one, that is, I already made a learning on the Google Teachable Machine.
Okay.
So like this, I can do in online. So now the question is, how can I deploy that model into any hardware, so that
Okay.
I can perform this on any hardware like Raspberry Pi or on any hardware? This is my question, sir. Yes,
okay.
sir.
That is why I have kept one session last day, that is containerizing your application. Like if you have seen in my case, I was not able to give you the example. Lot of other examples were there, image generated example. So in my case, I was using one technology. That means whatever the, and please remember, I think they have provided the code also for that, those Google people of that software. What we can do for deploying, we will be using container technology, because container technology is very lightweight. So in my case, whenever I have to deploy any application, and you have seen all the three application, it just took 1 minute to deploy all the three applications. So we can use this Docker and Docker Compose technologies there. I will be going into great detail in this technology. I think Saturday first session is mine. So if you are going to look at the topic, I will be discussing this technology. But in this limited time, it will not be possible. So whether it is Raspberry Pi or even other lightweight device, you can use Docker for the deployment. Docker is a DevOps type of thing. So we use Docker for deployments in any type of hardware. And once, like in my case, I have created this code. So once I'm going to take this code to Raspberry Pi or any type of hardware, I have to just run one command that I was running, and that application will be deployed. Like in my case, this AI application got deployed at 5000 port, ML at 5001, and then DL application got deployed at 5000. Again, in this case, you will be able. So Docker and Kubernetes are the technology. If you want to deploy at scale, then Kubernetes is the technology.
Yes, sir. Thank you, sir. Thank you.
Okay.
Definitely, we're waiting for our session.
In that session, I will be covering. Today, I've just run the command. Then I will go the behind the scene. Today, I've just shown the front end of the switch shop. That day, I will be showing that back end, how they create those switches.
Yes, sir. We understood how an industry person giving a lecture, how it will be useful for the academia people. Yes. Really, thank you, sir. Thank you for our session, sir.
Okay, sir. There was a limitation of time, so any other question? Another 2 or 3 minutes, because next speaker is already there, and in my case, I'm very punctual about the timings. If Gaurav, you are there, sir, I will another 2 minutes because my session got started. Any other questions, please? Otherwise, I will close the session.
Sir, excuse me. This is Dr. Meenakshi from Tamil Nadu. Yes, I have one question, sir.
Yes.
Whether learning computer vision, deep learning, and other things, whether we need to have some fundamental knowledge of image processing, whether it's essential, because most of the concepts comes from digital image processing, where we are not offering such courses to our students, but giving the ideas directly. That is computer. Whenever we are handling computer vision, we, as a prerequisite, we don't give image processing. Whether that's okay, or we need to have some fundamentals to be covered.
Actually, what is happening these days, I always call these the generation is Maggie generation. That means Maggie noodle generation. They want each and everything quickly. But I'm of the view that when we are into certain concept, you should make fundamentals clear, because then they will be able to, because lot of companies jobs in car. Why? Because persons they do not have fundamental clear. In my case, I have got lot of students are there, but they are always able to retain the job, because in my case, I always test fundamental should be clear. So my personal viewpoint is there, when you're taking your students to these computer vision, make those fundamentals clear, which will be very useful in later stages. So I'm of not that of 2-minute noodle. I just want the proper method. I will create my own those noodles. I will bake that type of things, a long process. So it will teach me hundreds of things, and the control will be much more.
Okay. Thank you, sir. Thank you.
Okay. Any other question? Then I will close. Any other question? Another question, then I will close.
Sir, good evening, sir.
Yes, ma'am. Yes.
So in continuation with the madam's question, so we should have the knowledge of mathematics, linear algebra, and OpenCV. Is there anything we need to learn thoroughly, sir?
These are the basic, because sometimes like in my case, I have given the demos. You are able to understand, but if you have to go into the deep, if I'm thinking about as a teacher, so always it should be deep. Even if a certain person, they have to develop certain application, if fundamentals are clear, how this thing is happening, just simply running the code. These days we know that code is available already on AI platforms. You can, but behind the scene, if you are able to understand those things, it will, again, so many things are there. I always say, when you're working, please try to clear your fundamentals also. Like in my case, whenever I'm learning certain technology, whenever I get that time, whatever fundamentals are not clear, whatever behind the techniques are there, I try to understand those techniques. Then I am able to. So in my case, I will give the answer that it is better if you are going to teach these type of things. Is this okay, ma'am?
Yes, sir. Thank you so much.
Hello. Hello.
Yes, ma'am. Yes.
Very, yeah, a very good evening, sir. This is Dr. Bharati Kaude from Pune, Maharashtra.
Yes, ma'am.
I'm glad to be part of this PDP, sir, and it is very nice, informative, and useful PDP. I request to share the PPTs and code files so that we can try on that. My question is,
Yes.
I'm teaching the Internet of Things subject for the first time round. So
Okay.
it is very interesting and a number of, as per our curriculum, my students are developing various systems, projects works. So it is
Okay.
very knowledgeable things in terms of how these particular projects can be incorporated in terms of our solving the challenges of societal problems. So how
Yes,
we
ma'am.
can incorporate these things along with the ML and DL. So that is my question.
Mean how can you incorporate those, madam? Actually, what happens, when you are suppose you are deploying certain applications for the agriculture people. So now that mean suppose for the whole, I'm taking you are deploying for Punjab farmers deploying certain application. Now a lot of data will be there. Now we have to analyze this type of data. So for that you can use your local models also, or what you can do, you can use your cloud also. And various cloud services, they provide certain device, like when you are deploying this type of IoT devices, you can take that Raspberry Pi, and Raspberry Pi, we have got certain edge technology software is available, which is provided by the AWS people, that is called AWS Green Grass Core. So what we can do, we can attach our devices with this, and there itself we can deploy machine learning or AI models there. That is one. That means on edge devices. Or what you can do, whatever data you are capturing, please, you can use this cloud type of services in which like Amazon recognition is there. Lot of 10 to 15 other services are there which you can use for that purpose. So yes, you can integrate like security incidents are there. Then again, you can integrate that with your these AI, that type of things. Definitely, it can be integrated, ma'am.
Thank you
Hello.
so much, sir. Thank you.
Okay.
Sir, sorry. Again, one
Yes.
more question. Can you
Yes.
suggest any self-learning platform through which we can learn recent technology? Because nowadays, the technology which is yesterday, it has become obsolete today. So to keep ourselves updated, can you suggest any self-learning platform which gives some detailed information to upskill our knowledge?
In my case, ma'am, first of all, we have to, when we are attending certain conferences and when we are, in my case, most of the time, I always keep in touch with my students, or I have always said, whenever you are going to find certain thing, please inform. Do not send any gift to me, but just send the technology's name and resources name. Now, these days, what happens, like suppose I was talking that whenever you have to deploy certain applications, you have to use Docker and Kubernetes. This is the latest technology. Suppose you want to learn this type of technology. Please, ma'am, a lot of online resources are available. Playgrounds are available in which you do not need to install anything. Very good tutorials are available. And certain platforms are available, like Udemy type of things, where courses are just available for 3 to 400 rupees. And world's best, you can say, authors or instructors, they are available there in that platform. So in my case, or I always suggest to the people, please go to these type of platform, Udemy type of platform, or just try to search. Like in my case, when I was searching whether how to teach you people how to learn what is CNN is there. there. So already certain tutorials are online demos are there, which is going to explain in very clear way this type of things. Then TensorFlow Playground is there. For Docker, it is there. That means different online resources there are available. And third thing I always do, I try to buy certain books on that technology. So that is
Okay.
how I go. That is
Okay.
my.
Okay. Thank you, sir. Thank you.
No, I will not take any other question because next speaker is there. So I'm concluding the session. So I will again meet on Saturday. Thank you for attending the session.
Thank you so much, sir, to our esteemed speaker, Mr. Bipin Gupta, for such an insightful and enriching sessions on deep learning and computer vision and overview. We truly appreciate the time and effort Sir has taken to share his deep industry experience and knowledge with all of us. Now, moving ahead with our session 2 of this AICTE ATAL sponsored faculty development program on deep learning for computer vision. The topic for this session is pre-trained models for computer vision. We are privileged to have with us Mr. Gaurav Kumar, Director of Magma Research and Consultancy Services, Ambala, Karnataka, Haryana, as our expert speaker for this session. Dr. Gaurav Kumar is a session resource person, trainer, subject matter expert, and speaker with over 24 years of experience across teaching, industry, and research. He is the founder and director of Magma Research and Consultancy Services, offering consulting in learning and development, instructional design, curriculum development, content strategy, and related dimensions. He has delivered sessions in 650 plus technical workshops and training programs for leading academic institutions and government organizations, including NITTR, NITs, Central Universities, MSME, DOPT, defense staff, and law enforcement agencies. His core domains include open source technologies, artificial intelligence, data science, wave engineering, blockchain, fintech, cybersecurity, digital forensics, software testing, quantum computing, e-tools, and LMS implementations. Known for the practical hands-on approach, he regularly delivers sessions in workshops, FDPs, STCs, webinars, and technical events, and also served as jury member in national level technical competitions. Sir, please proceed.
Thank you, ma'am. Good evening to all the participants. We are starting this session. Dear all, I have shared my screen. Kindly confirm in chat window whether screen is visible and you are getting audio clearly so that we can move ahead with the content as per the schedule. Whether screen is visible and you are getting audio clearly, I have shared my presentation. Okay. So, dear participants, in this session, we will discuss about different implementation aspects of pre-trained models for computer vision as well as related technologies associated to deep learning. In this session, we will see by which way we will be able to integrate pre-trained deep learning models, computer vision models, or even NLP-based models for research-based applications using free and open source libraries. As all of you are already aware, you might have worked on machine learning. You are already aware with Python programming. You might have seen that classically for deep learning based implementations, either we use PyTorch or TensorFlow. Along with that, lots of other technologies associated. OpenCV is there, BoofCV, Kiano. So we will see, first of all, we will discuss about different use cases of pre-trained models for research projects, whether you are working on some particular research task, academic research project, or corporate research project. Related to computer vision, natural language processing, speech recognition, biometric analysis, gestures, behavioral analysis. And in addition to that, you might have seen that nowadays we are in the era of generative AI. In this session, we will discuss about that part also, how to integrate large language models, retrieval augmented generation with pre-trained implementations. Along with that, we will discuss about very important terms, very important concepts in computer vision, in deep learning, like transfer learning, fine tuning of some particular models, fine tuning or transfer learning of pre-trained models. If you are working on some custom model, for example, you are working on satellite data and you want to take some pre-trained model. So in that particular pre-trained model, your images are not available, obviously. So how to put our own data, how to freeze or unfreeze the layers. So to some extent, we will see about that particular part, because in online session, there are certain constraints related to implementations. So I will try to cover some particular implementations in which few images can be inserted and those we can train. And along with that, we will see how to integrate large language models, retrieval augmented generation, vector databases, because nowadays we are in the era of generative AI. In generative AI, lots of AI platforms available: ChatGPT, Gemini, Stable Diffusion, Dale, thousands of platforms. At backend of these, there are pre-trained models. But when we discuss about pre-trained models or backend models of ChatGPT, Gemini, Bard, or Google AI Studio or Notebook LM, then we do not use very classical term pre-trained model, because that is not a small model. These models are a huge model, giant models, big models. And those big, giant or huge models we relate with large language models. And each and every large language model is pre-trained. At backend of ChatGPT, you might have heard that LLM is working. But what is actually that LLM? That is a pre-trained. That is pre-trained from so many books, from millions of books, from millions of tweets, millions of articles, so many web scraping. After that, that LLM is trained. But at the base level, that is large language model. So we will see that part. And when we integrate real-time searching, when we integrate real-time data extraction, real-time addition of data, then it is associated with a particular term that is known as retrieval augmented generation. When ChatGPT was launched around 4 years back, you might have seen at that particular time, only particular data associated to some particular timestamp, it was available. Real-time search was not available initially around 3 to 4 years back. But nowadays, when we are searching something on ChatGPT or Gemini, they are fetching data from its large language model, from its pre-trained model. Along with that, it is fetching data from Twitter, Facebook, Reddit, so many websites, and after that it is augmenting, it is adding the data in its pre-trained model. So in real time, fine tuning is going on. In real time, that transfer learning is going on. So what we were doing around 5 to 6 years back, manually, by transfer learning, by fine tuning, these things are going on in real time nowadays in ChatGPT. Whatever we are searching, if it is new to ChatGPT, it will fetch data from internet, it will add it. Add means fine tuning, transfer learning, retraining, and then it will give you prediction. And with this particular concept, with these specific concepts, there is one more term that is known as vector database. We should be clear about this particular term. If you are working on research projects, if you are teaching to students, we are guiding some minor projects or major projects, we are preparing our students for their better placements, then rather than classical databases like Oracle, MySQL, or SQL Server, nowadays vector databases are working at the back end of pre-trained models. Which are those vector databases? So, however, this particular topic I will cover separately when we will discuss about cloud deployment. So this one, Pinecone, Milvus, FAISS, and so many other vector databases. Nowadays, at the back end of pre-trained models, giant models, large language models, vector databases are used. You can see that if we are working on generative AI based applications, generative AI based applications for computer vision, for speech, for whatever it is. So even if you are working on IoT based applications, for example, I want to fetch real-time signals from sensors. I want to fetch real-time data from some specific hotspots or some specific sensing area, some satellite. In that case, we have to work with these applications: Milvus, FAISS, Facebook AI similarity search. You can see that these are vector databases, and nowadays in industrial applications, in research based applications, these are used. So you can see its performance, how many queries are associated. Okay, so these terms, these concepts we will discuss, and in few lines of code, you can see that in 4 to 5 lines of code, we will see how to train a particular model, how to work on pre-trained models, by which way we will be able to add our own data and working with vector databases at backend. Along with that, there are so many other platforms like Clips. Okay, Clip platform, that also we will discuss. Now, dear participants, first of all, we will discuss about some real world scenarios, some use cases, implementation aspects of pre-trained models where we can use. As all of you are academicians, you might be working on some research projects, whether these are funded projects or social projects. Many times we work with Arduino, BeagleBone Black, or Raspberry Pi, and so many other open source hardware available. And we generally strive or struggle for good research ideas. So such type of research projects we can integrate, we can implement using low cost hardware with computer vision. All of these applications are computer vision based applications. You might have seen in defense based applications, in law enforcement based applications, drones are used. Okay, however, drone technology is associated with IoT, Internet of Things. Okay, along with that, we use a high quality wireless network, 5G. Nowadays, 6G is also under research. But by which technology we will be able to capture data? By which technology we will be able to match certain target? For example, we are proposing a research project. We are working on a particular task like swarm drones. So obviously a particular target should be shot down. Target will be matched only if our computer vision based application is working fine. For that, we can use pre-trained model. For example, I'm having some sensors, I'm having a particular drone architecture. We have integrated each and everything, but by which way we will train the data related to target? For that, we will use computer vision, OpenCV based applications. In military operations, you might have seen these are widely used in almost every sector. These are already integrated. Okay, these are not only associated with IoT, because when we see such type of devices, such type of robotic applications, we think that these are IoT based applications. But along with, because IoT can't work independently, along with IoT, we must need computer vision. You might have seen in different cricket matches, particularly IPL matches, and there was a particular robotic dog. So this is also a computer vision based application. However, there are sensors, some particular actuators, some specific devices. Okay, it is connected to satellite, it is connected to base station, but by which way it is identifying the obstacle? By which way this particular robot is identifying the direction, in which particular direction it should move, left, right? It should not collide with any player, it should not collide with ball, or it should not collide with any boundary wall. It should be independent, it should be moving independently, taking care of the obstacles in surrounding. Taking care of the obstacle means computer vision. Okay, so if we want to work with such projects, in that case, we have a very good option of integration of pre-trained models. Pre-trained models means all objects of this world, each and everything, each and every image related to the world, it should be available in a database. Now, for example, we want to work on this project. We want to work on this particular task, drone-based application or robotic dog. In that case, by how it is possible that we will train each and every object in a particular database, in a particular model? Different types of trees, different types of human beings, different height, different types of obstacles. How it is possible? So if we will work on this particular task manually, we will have to train millions of images. For example, we want to work on a robotic application for home automation, for our home task. In that case, we will have to train each and every object, each and every image, like refrigerator, okay, AC, chairs. So there are so many different types of images. How it is possible for any researcher to take snaps of different types of images and then train it? And after that, we will put it in Raspberry Pi or whatever it is. Rather than working from scratch, rather than reinvention of wheel, what we can do, we can take help of pre-trained models. Pre-trained model means it is having all images of this world, all animals, all creatures, each and every type of object, whether it is living object, non-living object, and after that it will work. Not only for law enforcement or entertainment, we can work we can integrate in manufacturing sector. In speech recognition also, pre-trained models are used. You might have seen, even you also might have used Amazon Alexa. What is Amazon Alexa? At the back end of Amazon Alexa, there is pre-trained model. It is able to identify what you are saying, what is meaning of your sentence, what you want to say with your particular statement. And after that, it will identify your instruction and it will perform the action. Same thing happens in case of Fire Stick, Amazon Fire Stick. We want to watch YouTube, we want to watch a specific web series, we release audio, and that audio is recognized with a pre-trained model. So pre-trained models are not only for computer vision or speech recognition, for every sector, even AI integrated medical devices. Nowadays, you might have seen that mobile integrated ultrasound machine is deployed. If you will explore a machine with name Butterfly, okay, so handheld or pocket based ultrasound machine, similar to you might have seen nowadays almost every chemist, almost every medical shop is having a particular device to capture BP level or sugar level, diabetic level. Same way, ultrasound machines are available, handheld. However, there are so many security, privacy, and integrity issues. So many social issues are also there, because there may be threats also if such machines are deployed for general public, because everybody, in that case, everybody will be able to perform ultrasound without any doctor. But such things are available, and all of these are working with help of pre-trained models at the back end. As just now we have discussed related to ChatGPT, Gemini. At back end of Gemini, at back end of ChatGPT, there is pre-trained model. Okay, but that is huge model. So many books, so many articles, millions, trillions of sources are extracted from different millions of research papers are put in a particular pre-trained model, and then we are asking the questions. Okay, so these are application areas, whether it is number plate detection. Okay, so you can work on these intelligent applications for agriculture. So for these applications also, we must need computer vision, real-time object detection, real-time crop analytics. You want to see growth of a particular crop. Okay, along with computer vision, you can we can fetch some particular chemical data, some specific data related to humidity, temperature, or other aspects in that particular farming area. Okay, so all of these aspects, all of these implementations are associated with computer vision. Along with that, IoT, because nowadays we are in the era of multidisciplinary research, interdisciplinary research. We are in most of the segments, single domain research is not going on. Almost every person is working on multidisciplinary research, and for multidisciplinary research, we have to integrate different technologies: computer vision with IoT, okay, computer vision with blockchain, IoT with blockchain and computer vision. Okay, so whenever there is a task related to security of biometric, okay, biometric is related to computer vision, but security of biometric features with blockchain. It's broadcasting, it's communication, that can be done with IoT. So such type of interdisciplinary, such type of merged approaches can be worked out for research-based applications. Okay, now we will see, if we want to work with these applications, we want to work with some realistic research projects, then which are key phases? These are the key phases. Okay, If we want to, if we discuss about broader aspects, broader way, in broader way, this is the format. Okay, either we work on pre-trained model. For example, we want to work with robotic application. In robotic application, either we will work on pre-trained models or we will work on custom model. Custom model means I don't want to take any pre-trained model. I don't want to take any pre-built images. I want to take my own images. In that case, we will go for custom model. I will work on matrices. We will work on algebraic equations. We will work on some particular tensors manually, but it is very time consuming and performance will be a very big issue. Generally, in custom model, in self-created models from scratch, we face problems of performance accuracy. But if we are working on pre-trained models, in that case, we generally get very good results. Okay. In most of the research projects, in most of the research-based applications, we work with pre-trained models. Pre-trained models means different models which are already trained on different data sets. Okay, now if we discuss about different libraries, so many libraries available which provides you pre-trained models. OpenCV, BoofCV, okay, Luminoth is also there. So you can see OpenCV. Is this audible and visible to all participants? Kindly confirm in chat.
Yes, sir.
Are you getting the content properly? So you can see whether you are working on biometric application or any other application. So either you can work on OpenCV, SimpleCV, YOLO, Lobe, BoofCV. So many platforms available and different cloud-based applications are also integrated. Now, first of all, we will see which pre-trained models are available very quickly. So only two to three slides I will show you now. After that, I will come directly to implementation part. Okay, we will see how to work on pre-trained models in practical demonstration, and by which way we will be able to work on fine-tuning part, because that is very important. Fine-tuning, transfer learning. What is pre-trained? Pre-trained models means these models are already trained on millions of images on a huge data set. One of the very popular data set is ImageNet. Okay, ImageNet data set, CocoNet, Coco data set is also available. So you can see that this one, ImageNet data set. What is at the back end of ImageNet dataset? You can see that millions of images, training images. How many validation images are there? It means if I want to work with robotic application, for example, I want to I want to work on a robot, I want to work on a drone. So to recognize any object with object recognition algorithm, obviously I will have to train the database. I will have to train a particular model. So rather than taking own images from on camera, what we can do, we can take these images. These are already available and pre-tested. 1000 object classes. These images are also already integrated. All data sets, Coco dataset images. So you can directly search Coco dataset. This one, common objects. At backend of pre-trained models, these data sets are integrated. So all animals of this world, all types of creatures of this world, all living objects, different types of non-living objects. For example, I want to work on a robotic application for home automation or for smart office automation. Obviously, I will have to give each and every image to that model, that this is refrigerator, this is AC, this is cooler, this one is washing machine, so that it should not collide with that. it should be able to identify that it is a washing machine. It should not collide. This is a leaf, it can collide, because if that robot will collide with leaf, then nothing will happen. If it will collide with some dust particle, nothing will happen. But if it will collide with some tree, then that robot can be damaged. So by which way we will give so many images? How to train each and every image? First of all, taking image and then training. Rather than that, we can directly take these models. These are pre-trained models. Exception, VGG16, VGG19, ResNet. These are pre-trained models. And at back end of these pre-trained models, so many images are already available. Simply in 5 to 6 lines of code, in 10 lines of code, we will be able to work on a particular object recognition based application. You can use any of these. Okay. So these are classical pre-trained models. Classical pre-trained models means each and every object. For example, I want to recognize. Okay, I will show you its demo also. So many images I have already taken, like fingerprint, MRI images, X-ray. For example, I want to predict what is this. Okay, whether it is a car or not. Okay, so this one, what is this particular object? I want to predict this object. So by which way we will be able to predict? For example, I want to predict this particular object. There are so many types of cars, so many types of vehicles in this world. How it is possible that we will take image of each and every vehicle and then we will train? Rather than taking our own images, what we can do, we can use pre-trained model. In pre-trained model, it is already given that if this is the shape, then it is a car. If this one is the shape, it is some particular creature. If this one is the shape, then it is MRI. If this one is the shape, it is X-ray image. If I'm working on some particular data, like medical data, satellite data, for example, this is my satellite data. Okay, dense forest. In that case, we will have to work on fine-tuning part. Okay, so first of all, very quickly we will see by which way we work on these models. So some models, first of all, I will show which models we generally use. These are general purpose pre-trained models. General purpose models, AICTE, VGG16, and how many parameters are there, how many layers are there. Layers means how many accuracy. For example, I need high accuracy. Okay, very high accuracy. In that case, 201 layers. You can see that. So high accuracy layer-based pre-trained model I will use. How many parameters are there? ResNet. These are general purpose. Now, in these general purpose, there are every type of object. Okay, there are insects, human beings, different types of creatures, different types of vehicles. Okay, but for example, my area of research is X-ray images, pneumonia based X-ray images, or cancer based some particular ultrasound, or some cyst based MRI. In that case, what I will do, many times we have seen that new researchers, particularly new researchers, they directly use these models, these pre-trained models. Okay, without taking care of the aspect whether their data is fit or not. Okay, randomly many people use ResNet, randomly people use VGG19. Okay, for example, my area of work is iris detection. Okay, so for iris detection we can use any of these, but which is best fit? This is the list of best fit models. If I am working on eyes, then VGGNet. Skin, VGGNet. Brain, lungs. If we are working on ultrasound, then Inception model. Endoscopy, Inception. Okay, so for different type of diseases, for different types of objects, for example, I want to work with satellite data. Okay, in that case we can use VGGNet. We are working on some geospatial data. In that case also we can use VGGNet, AICTE. So we have to see which particular type of pre-trained model will be fit. Okay, now we will see if how to integrate these models in code, and once these codes are working, after that we can put it in some open source board, whether it is Raspberry Pi or Arduino, BeagleBone, or whatever it is. Okay, so this is the list. At end of this session, I will share this presentation to all of you. So if you are working on chest X-ray, then ChexNet, dermatology based implementation, Inception V3. Okay, so for different type of diseases, for different types of problems, different types of data sets, we have to select a particular pre-trained model. Okay, for example, I want to generate some particular text, so in that case we will use Gemini or Chat GPT. If I want to generate images, then we will use Bale, Stable Diffusion, so many other. So which large language model, which particular pre-trained model we want to use, that we have to select. Okay, so at end of this session, I will share this PPT to all of you, in which this list is available. And if I want to integrate it with IoT, so in that case we work with MQTT. For example, real-time computer vision with computer vision pre-trained model, and those pre-trained models we want to link with particular base station. We want to link with IoT scenario. For that, we can use MQTT, message queuing telemetry transport, for IoT and its integration with computer vision. Now we will see some implementations, and then it will be more clear to all of you what we want to say. So some codes I have already prepared. So at end of this session, I will share these notebooks also. So connect, this is Google Colab notebook. Now very first implementation I'm showing you related to prediction of some objects. For example, this one is some image that is taken, that is fetched from some webcam, from some CCTV, from some camera in drone or robot, whether it is robotic dog or drone or whatever it is. We want to predict what is this. Now, without training any particular model, without training any data set, what we are doing, we are taking care, we are directly fetching pre-trained models. So see this code very carefully. I will show those points which are associated to pre-trained. You can see that we are using PyTorch. Okay, for you can see that load pre-trained model, models.resnet, resnet 50. So you can see that it is, this particular code is only 15 to 20 lines of code. And in this particular code, we have directly imported ResNet 50. In ResNet 50 at backend, which database we are using? We are taking the database of this ImageNet classes. You can see that this one is ImageNet classes. This ImageNet classes.txt file, what is inside this? This is taken from this portal. Okay, so in this particular web link, each and everything is available. So you can see that all labels. Okay, millions of images are already trained. So in a single line of code, download image net labels. We have given its URL, which pre-trained model we are using. For example, this is ResNet 50 model we are using. Pre-trained, this is true, it is pre-trained model. Pre-trained model means we are not training any data, we are not giving our own data. It will take care of the data, it will link data from ImageNet dataset from this portal, this one, ImageNet. Okay, and I am giving only test image, test.jpg. Where is my test.jpg? This is my test.jpg. Now I want to see what is this image. Okay, what is label of this particular image. So on execution, it will ask me to upload the image. Okay, so it is executing. So you can see that it is fetching, and so ResNet 50, this particular model is linked. Now I will upload the image which I want to predict. Okay, which specific image I want to check. Okay, test.jpg. Now you can see that it is giving me probability. This one is a sports car, this one is racer, and these are the labels. Okay, in same way, for example, for some other image I want to predict any other image. Okay, now I'm taking this one sq. This one is sq.jpg. Okay, now I want to predict. Now, whether it is a robotic dog or drone or whatever it is, we want to predict what is this, and depending upon this, we want to perform some action. We want that drone should perform action, whether to collide, whether to fire some weapon, or to change the direction. Okay, first of all, it should know what is this. So this image we are checking with pre-trained model. Okay, so this one sq.jpg. So in this particular code, we have not given any particular label. You can see that it is fox squirrel, highest value it is associated with fox squirrel. But you can see that in this particular code, we have not given any squirrel database. We have not given any car database. Okay, only few lines of code, and those scripts, those syntax are related to fetching the pre-trained model. Okay, so this is known as working on a pre-built model, on a pre-trained model without giving our own data. We will give our own data only for prediction. Okay, whether you want to use it for computer vision or speech recognition. Okay, for speech recognition also you can use. For example, you want to work on sentiment data analysis. Okay, in sentiment data analysis, for example, this one. Okay, so this is also the implementation. This one is also associated with pre-trained model. Transformers are also associated with pre-trained models at the back end. Okay, so either you can import complete model, or what you can do, you can link a transformer. So what is a transformer? Transformer is an architecture, is a neural network architecture. At back end of that neural network architecture, there is a pre-trained model. Okay, which pre-trained model? Sentiment analysis. You can see that in 4 to 5 lines of code. I want to predict what this particular text is all about, whether it is a positive or negative. For example, we are working on sentiment data analysis, emotion data analysis, polarity score. We have some Amazon reviews, Flipkart reviews. We want to predict whether these reviews are positive or negative. So what we will do, rather than giving each and every word, rather than giving each and every label, what we can do, we will use this pre-trained model via pipeline. Okay, so what is transformer? At back end of transformer, there is pre-trained model, and transformer is an architecture. So you can see that, and to use that transformer, we use pipeline. So you can see, first is this movie. The movie was not good. It is negative, 99.97%. It is out of 1. So out of 100%, it will show, it will be 99.97% negative. And second review, product is good, it is 99.98% positive. Okay, even if you want to work on some ChatGPT like application, some generative AI based application, if I want to summarize it in ChatGPT, in Gemini, many times we work on text summarization. Okay, so for that purpose also we can work with pipelining. Okay, what is pipelining? Pipelining is the way to use transformer. What is transformer? Transformer is using a pre-trained model along with it, in which data is already available, data is already trained, and then we want to predict something. Okay, so for example, we want to summarize this particular data. So you can see that in only 5 to 6 lines of code. So if we want to develop an application similar to ChatGPT, so which model we are using? This is the model. And where these models are available. Now the question comes, from where we will come to know how many total models are available, how many types of models available, where list is available related to pre-trained models or corporate models. There is a website, there is a portal, that is Hugging Face. Millions. Okay, so many options available. So you will get so many different types of pre-trained models available here. You can see that for audio to text, text to audio, text to text. If you are working on computer vision, depth estimation, object detection, image classification. For example, we want to work on image classification. In image classification, which model I want to use? Okay, which specific model we want to use? So all corporate models are available here. You can see that. Different corporate models. Which model, which pre-trained model I want to use? Google VIT, Microsoft. If I want to work with NVIDIA model, you can see NVIDIA. Okay, I want to use OpenAI, that is the developer of ChatGPT. You can see Microsoft ResNet. This Microsoft ResNet 50 that we have used in code. This one. Okay, just now we have used same thing in code, but it is actually available on this portal. Okay, for example, I want to test this pre-trained model. Okay, this one. Simply upload the image. For example, I want to see what is this particular object we want to predict. So it will give me probability. So this one is car, sports car, 0.991. It means 99.1%. Racing car, this one, car wheel. In same way, for example, some other object like this one, bike. This is, you can see disc brake, moped, motor scooter. Okay, this one. So if I want to use this model, if I want to use this pre-trained model, so they have given the transformer in form of transformer. So one way is that one way to use this pre-trained model is to take its complete code. Okay, and which particular database they have used at the backend, which specific model they are using. So you can see, first of all, we will check which database it is using. It is making use of COCO dataset. You can see that it is also making use of COCO dataset. Along with that, ImageNet classes. It means merger of both COCO as well as ImageNet. So they are also using pre-built images, already pre-built images, and this is the code. So if I want to use this pre-trained model in my robot, in my drone, so I will integrate, we will use this pre-trained model in form of transformer. You can see this is transformer. So what is transformer? It is the way, this is the method, it is the architecture to use a particular model. Which model? This one. You can see that from pre-trained Google VIT base, from pre-trained Google VIT base, and in 6 to 7 lines of code, we will be able to train our robot, we will be able to train our machine or any particular device, whether it is a drone or whatever it is. Is this clear to all of you? To some extent, kindly confirm. To some extent, is it clear to all participants up to this point?
Yes,
Whatever.
sir.
Yes, sir.
Okay. Because in a short time span, it might be difficult, but I'm trying to cover these points. Up to this point, are you getting the content properly and the speed is fine? Are you understanding the concepts or not?
Yes, sir.
Sure, sir.
Okay. Now, dear participants, we will see one very important point. So these are pre-trained models. So and millions, so many models, hundreds of models available. For example, I want to see OpenAI model, OpenAI pre-trained model. You can see OpenAI GPT, OpenAI GPT OSS. So if I want to take a particular model that ChatGPT is using, that Gemini is using, so we will be able to use. If you want to work with some context-based models, in that case, we use Model Zoo. context-based models. Context-based models, you can see model zoo. For which application you want to work. For example, I want to work with X-ray. My area of work is related to X-ray images. So it is giving me that pre-trained model. You can see that chest X-ray and click. It is on the basis of ResNet. So you can see that ResNet 50 is updated. If I want to work with MRI, okay, so you can see that this one for MRI, brain segmentation, SegNet CMR. Okay, so browse categories. You can see in which domain you want to work: computer vision, reinforcement learning, natural language processing, or any other. So this one. If I want to use, for example, this particular model, okay, this, so simply click, it will give you the code, get model, and this one is for pose analytics. Okay, in form of transformer, we will be able to use it. Now, dear participants, we will come to our point that is very, very important as per the current scenario of research. That is known as large language models. Nowadays, we are in the era of generative AI, AI chatbots. For almost every application, you might have seen chatbots are available. For content creation, image creation, multimedia content, if you want to generate lecture notes, you want to generate presentations, for each and everything, for each and every application, chatbots are available. Now, we want to link generative AI with our own data set. Okay, we will come to that particular part. So first of all, I'm downloading this notebook and I will share to all of you. We will work on computer vision based application for image indexing in large language model retrieval augmented generation. First of all, we will see what we are going to do. Okay, I'm having some images. Okay, so in very first demonstration, we will work on clip based implementation. Clip means contrastive language image pre-training by OpenAI. Interconnection or linking of images and text in same embedding space. What is meaning of this? First of all, we will make this point very clear. What we want to say with this statement. You might have heard, you might have studied that when we work on classical databases, we take a particular data type. For example, I want to store some number. We use integer, long integer, short int, or whatever it is. If I want to store date, we use date data type. For name, we use char, varchar, or whatever it is. For images, we use lob, below. We generally do not integrate images and text in same. In classical databases, we can't store image data as well as text in same field. For example, we have defined a schema. Okay, why we are discussing it? Because when we go for pre-training, when we go for generative AI, where is our database? Database is at the back end, and it is in form of vector database. Vector database means it can embed everything. It can embed video, it can embed text, images in same embedding space. No need to separate that this is image, this is text, this is video, this is calendar, it is date of birth. Each and everything will be on same space. That's where the concept of optimization comes, performance. That's why ChatGPT, Gemini, they are giving you very quick results, because at the back end, vector databases are working, not classical database, SQL Server or MySQL or MS Access. So what is the vector database? Vector database means each and every data will be converted to vector. Vector means number, some particular numeric format, some particular vector format, it will be converted and it will be stored at the backend. ChatGPT, Gemini, Bard, AI Studio, whatever it is, Dale, Stable Diffusion, each and every AI-based application nowadays, they are making use of vector databases at the backend for storage of data, for pre-training. Okay. Now what we are doing, what we want to perform in this particular implementation. Okay. First of all, I want to upload some images. For example, I'm having these images. Few cars I will upload. This one is car, bike, squirrel. Okay. And in 5 to 10 lines of code, not very lengthy codes. Using vector database, it will be automatically identified whether it is a car or a bike. It means no need to extract features. Features will be identified automatically. For example, I'm using these fingerprints. I'm uploading these 5 fingerprints. And I want to identify a particular type of fingerprint. One way is that I will train it. I will have to convert in a particular matrix format. We will convert RGB to gray. After that, training, so many other things in classical deep learning. If we are using convolutional network or RNN, rather than using convolutional network, rather than using RNN, we can directly use vector database. Vector database already knows each and every pattern. And that is the major performance aspect nowadays. So we will see this particular part. So first of all, I am installing these packages. FAISS, OpenClip. What is FAISS? For storing the features of the images vector. So this is Facebook AI similarity search. Okay, this one FAISS. If you want to use Pinecone can also be used, vector database. It will automatically identify the vectors. Okay, so you can see that this one. And these are available in open source distribution. Many databases are available in open source distribution. Okay, no need to pay anything. You can see open source vector database for generative AI based applications. For example, I want to create a pre-trained model for my institute, for my organization. Okay, so rather than using Oracle MS Access, I will use Milvus, I will use Pinecone or Clip. Okay, so that each and every feature should be identified automatically. Now pip install PyTorch, FAISS CPU, and OpenClip Torch. So this interfacing we will use. Now some images we will upload. So this description also I have given here. Okay, so first of all, so I'm directly coming to that particular part. Some demonstrations related to realistic images. Some forest images I want to upload. Okay, satellite images. So very first implementation, we are working on satellite images. So this one is first image, satellite image, just demo I have taken. First image, second image, third image. Okay, these three images we have taken, these four images. Okay, these four images I want to train in vector database, and then we want to predict. So for uploading, we are using google.colab import files, files.upload, and with os.make dir, we are creating a directory so that these files will be uploaded. Okay, now I will run it, and I'm taking those images. So S1 to S4, these four images I am uploading. These four satellite images I have uploaded. Okay, this uploaded S1 to S4. These are S1 to S4. Now out of these S1 to S4, I want to get prediction. I want to fetch dense forest area. If I am working on classical deep learning, classical machine learning, or classical computer vision, in that case, it will be very time consuming, taking features, then segmentation. After that, we will go for some particular activation function. After activation function, we will see performance, then fine tuning, so many things. But if we are creating a model with clip, with vector databases, in that case, your model will be very, very fast, and quicker results you will be able to achieve. So you can see that this one, OpenAI pre-trained model we are using. Which model? So this one, VIT B32, it is pre-trained OpenAI, and where we want to store the data, we are using at the backend clip. Okay, clip. And now on execution, we want to see the retrieved images. Okay, so which query I have given? Dense forest area. I want to see only those images which are associated to dense forest area. Okay, so this query is similar to the query we give in ChatGPT. Okay, so if we want to give it a graphical user interface similar to ChatGPT, Gemini, or Dale, that can also be done with Gradio, with Streamlit. Okay, so this particular query we are giving, and you can see that out of 4 images, 3 images are extracted. We have uploaded 4 images of satellite, but dense forest area is associated with this one. These images are associated with dense forest area out of 4. Okay, top matches. By which way it is going on? Using clip matching. Using clip. And where is clip? You can see that it is a pre-trained OpenAI tokenizer. Which tokenizer it is using? VIT B32. Okay, so what we are doing, we are directly taking a particular pre-trained model, and we are simply uploading our images for analysis. In same way, for example, we want to work on fingerprints. Now I will show, first of all, I will show you fingerprints. Okay, this one is first, second, third, fourth, fifth. 5 fingerprints I want to train in my model. First, second, third, fourth, fifth. These are 5 images from f1.jpg to f5.jpg. So 5 fingerprints I will upload with google.upload.files. Okay, so from f1.jpg to f5.jpg we are uploading. With files.upload we have uploaded. Now I want to extract particular fingerprint like curve based. I want to see a particular fingerprint curve based or some particular pattern. With that particular pattern we will specify in our query. So where is our query? So this is the query, loop pattern fingerprint. I want to extract only those fingerprints. So you can see that we are not training any data. We are only giving the reference of pre-trained model of OpenAI, and it is create model and transform open clip. So what is open clip? That we have just discussed. It is taking the index, it is creating vector of each and every image, and you can see that in very less lines of code. And we have given loop pattern fingerprint. This is my query. Loop pattern fingerprint. In loop pattern fingerprint, these 3 images are given. I have uploaded 5 images. Out of 5 images, F3, F4, and F1. These are extracted related to loop. These are 3 loops, loop based. Okay. If I want to see whether others are also loop based, so this is not. So this one is not loop based. Okay. So out of this is not loop based. This one is loop based. This is loop based. Okay. So out of 5 images, it has identified this one. If I want to see, okay, if I want to give any other query, so we are directly querying on that particular database which we have just given, and without any GPU, we are not using any graphic processing unit. We are not using any graphic card. We are not using any TPU. Simple CPU with classical CPU we are working. Okay, loop pattern fingerprint without loop pattern. Now we'll see this one. Okay, so fingerprint, curve fingerprint. Now in curve fingerprint, F3, F1, and F2, we want to see those images. Okay. Top similar images. So similar images to this particular, and now this. These 3 images are extracted similar to a specific particular query. So curve fingerprint. Otherwise, if you will perform it in manual implementation of deep learning, it will be very, very time consuming. We will have to work on, first of all, we have to work on pre-processing. Whether we are working on deep learning or machine learning, first of all, we have to pre-process the data cleaning, transformation, after that segmentation, then feature point detection. But with vector databases, with this particular library that is nowadays used in Chat GPT, that is nowadays used in OpenAI or AI based applications, it is doing each and everything automatically. Okay. Clip, contrastive language image pre-training. So along with your classical implementations, you can integrate, and it is also a matter of research also. You can propose, you can write very good articles, very good papers on this. For example, comparative analysis of clip and classical image retraining, classical image training and performance evaluation. So one implementation with classical deep learning, with classical convolutional network, results can be fetched. Another implementation with clip. Okay, what is execution time in this? What is execution time in RNN, CNN, GRU? What is how much accuracy we are getting in this? How much accuracy we are getting in classical deep learning? So what we can do, some results we can fetch, comparative evaluation. And if we are confident that this particular demonstration, this implementation is working fine, then obviously we can propose it in future work. So these type of demonstrations. So one more implementation, for example, we want to work on some medical images. Okay, for example, some medical images we are having. We want to display For example, this one, X-ray issues, only those images which are having X-ray issues. I want to train this one, second, 1, 2, okay, this one, X-ray 1, this one is X-ray 2, and this one is MRI, okay. Some MRI images, some X-ray images we have trained, and after that we want to predict, we want to fetch only those X-rays, only those images which are having certain issues, pneumonia or whatever it is, okay, whatever disease, whatever diagnosis aspect, whatever or whatever disease we are analyzing, that we can identify. So in these we can use pre-trained models. So rather than working on pre-trained models, ResNet, GoogleNet, VGG16, what we can do, we can take these models, and these models are available on Hugging Face. Along with that, you can work with Model Zoo. Hundreds, thousands of models available, you can directly use. Okay, so you can see that for depth estimation, for zero-shot classification, for text summarization, that ChatGPT is doing nowadays. Okay, text to speech, text to audio. For example, I want to work on text to speech. So on this, so which model I want to use? I want to use Microsoft model. So this one is Vibe Voice from Microsoft. In same way, I want to use AOIoT. Okay, that can also be done. In same way, if you want to take any other model, like for computer vision, okay, only for computer vision, like image segmentation, image to video, video classification, mask generation, image to 3D. Click in image to 3D, you can see Microsoft model is available, Facebook model is also available. If I'm working, so as a new researcher, what we can do, so one implementation of Facebook, one implementation of Microsoft, one implementation of NVIDIA, comparative analysis. In that case, our comparative analysis work will also be done with good results, with actual results, rather than theoretical content. Okay. So you can see stability AI, this can also be implemented. So if I want to use it, so in that case, its transformers are available. Okay. So models, and in which programming language you want to work, you can go for filtering also. Okay, different filtering we can apply. So libraries, for which library I want to work, PyTorch, TensorFlow, JAX, transformers, or NAMO, FastAI, YOLO, okay, or task based. If I want to work with image to image or object detection, in object detection, NVIDIA model, I want to see this NVIDIA model. So this is NVIDIA. Okay, I want to use it. So this is the code. This one is script. This code is given in form of API. Okay, transformer is provided. We can put it in our Google Colab. Once it is running, then we can put in Raspberry Pi, Arduino, or whatever it is. Okay, wherever we want to deploy. We want to deploy it as web-based application, that can also be done. Okay, we want to deploy it on cloud. For example, this one, I want to check this specific. Okay, so we have uploaded. This is DataNet, DETR, and by which way we have to use it. This one, code is available, and now you can see car 96%. If I want to deploy it, so train Amazon SageMaker, we can link it with Amazon SageMaker. If I want to deploy on Spaces, okay, you can see that use this model as a transformer or Google Colab notebook or Kaggle kernels. So in form of transformer. So this code is, you can see that in 5 to 6 lines of code. From transformers import pipeline pre-trained model is data ResNet 50. If I want to use it in my collab auto model for object Facebook data ResNet 50. Okay, so here it is written. If I want to use from OpenAI, so we will use OpenAI VI, whatever it is, VI 32. Okay, that specific name we will put. If we want to use it in Google Colab notebook will be available. Okay, so these pre-trained models are widely used in corporate sector also. So you can see Qualcomm. Companies, corporate, they are also working on, they also integrate these pre-trained models for gesture recognition. Okay, rather than training your own model, training your own data, after that we will see what is confusion matrix, how much accuracy is there, how much error is there. It is very time consuming, and even after performing so many things manually, we do not get very high accuracy. So rather than reinvention of wheel, we can take these pre-trained models and we can deploy. Okay, we will discuss about deployment of these models on cloud also in next session. Okay, I will discuss that how to create its web-based application. For example, this application, I want to create its GUI. I want to upload it on a web browser. Okay, so you can see that. For example, this clip model from OpenAI VIT B32. Now it is working on only Google Colab. In next session, we will see I want to create its web-based application. I want to open it on web browser so that there will be a browse button. It will ask me to upload the images. It will ask me to write something similar to ChatGPT, and then it will give me prediction. So that part we will discuss in the session related to deployment of machine learning on cloud. Okay, in that we will discuss about 4 to 5 platforms, 4 to 5 different libraries using which we can create its GUI application. Okay, graphical user interface application. For, if I want to create its dashboard. Okay, because currently for research purpose it is fine. It is working on Google Colab notebook or it is working on console. That is fine. But if we want to give it professional interface, browser interface, we want to give some buttons, we want to give some text boxes. In that case, we will have to use it on cloud. So in next session, we will discuss about that part, deployment of deep learning and machine learning on cloud. Okay, so you can explore these tools. And now, dear participants, I am sharing this presentation and notebook to all of you so that you will be able to use it. And its link I will share in chat window. Kindly wait, and after uploading it, I will share its link in chat window, and then session will be open for your queries. Dear participants, I have uploaded this presentation, and its link I am sharing in chat window. Dear participants, simply click on this link and download, and kindly confirm whether this presentation and notebook is downloadable or not. Simply click on this link, and if you are not able to click on the link, then scan this QR code from your mobile phone. You will be redirected to this page where presentation and code is available. Now kindly confirm, is it accessible or not? Simply scan this QR code from your mobile phone and you will be redirected to this page. And kindly confirm, is it downloadable or not? And now session is open for your queries. If you have any query, you can ask. Whether this presentation is downloadable or not, kindly confirm. Whether you are able to access this URL, simply scan this QR from your phone. I am again sharing this QR in this format so that you will be able to see it. Just a minute. I am showing it again in this way. Okay, now dear participants, session is open for your queries, and if you have any query, you can ask. Meanwhile, you can scan this QR code to download this presentation and notebook. Any query from participants?
Good evening, sir.
Yes, ma'am. Good evening.
So mine is very simple question, sir. Sir, there are many libraries, more architectures, and many things are there, sir. So, what path to be followed to master in computer vision? Is there any particular path to excel in computer vision?
Okay, ma'am. To work in computer vision in a professional way, you can start with OpenCV. Actually, when we work with OpenCV, then most of the algorithms related to image processing, these are already available. Along with that, our base concepts should also be clear. So, base concepts, paradigms of image processing, any textbook you can take, and as far as implementation aspect is concerned, OpenCV, and after that, from OpenCV, you can directly move to vector databases. Okay. But
okay, sir.
Start as far as complete information is concerned, detailed information is concerned, you can achieve with OpenCV also. Okay, in OpenCV, each and everything can be done. Even video processing can also be done.
Okay, OpenCV is sufficient to learn computer vision, sir.
Yes, OpenCV is more than sufficient. If you are able to work only 60% of OpenCV library, your more than 90% work will be done. Okay, because it is a very huge library, thousands of algorithms available.
Thank you so much, sir. Thank you so much.
Any other query? And whether you got something or not, I don't know whether how many of you are aware with these terms, vector databases, RAG, LLMs. To how much extent you are clear, you understood these concepts, you can tell, you can message in chat box also.
Hello, sir.
Yes, ma'am, please.
Yes, your session was really very informative and engaging. So I have one query. Actually, what kind of predefined model should we use if we are working with the real-time bio-waste analysis? So you have told us that we can use this VGGNet for this fundus image or OCT image analysis, and
Yes.
for brain MRI we can use LXNet, right? So
Yes.
so I am actually I was searching for this, but I have not got much data sets. So as there is a lack of like scarcity of such data sets, and also privacy issues are there, right? So can you tell me?
Okay, actually, ma'am, in that case, you can work with ResNet, GoogleNet, AlexNet. These are very popular pre-trained models. And at back end of these ImageNet, Poco dataset, these are already integrated. So you can start with this. Okay, once you take start with these platforms, with these libraries, then you will be comfortable to adopt other libraries.
Okay.
First of all, you should take start. Actually, what happens, we have seen that many times, specifically new researchers in any technology, they fear, they have a fear of starting. They have fear of initiating. Actually, what they do, generally what people do, taking code from different sources and running it. But when we want to create our own code, then we get stuck. Rather than directly taking code and executing, very small code you can try. For example, only single image. Or take one example, training only 2 images and prediction of single image. Actually, this code will be of 10 to 15 lines, but that 10 to 15 lines of code will clear your concepts. It will give you confidence. It will boost your confidence. If I will take a source code of 500 lines of code, 200 lines of code, in that case, we get panic. Okay, so see, do not panic on starting with some implementation. So take very small implementation like hello world. Okay, by which way we have to work, then 2 images, 3 images, and then move ahead. After that, your concepts will be very, very clear.
Yeah. Okay. Thank
Okay,
you,
and
sir.
nowadays ChatGPT is available. Nowadays Copilot is available. Okay, in Copilot, you can generate very simple code. Any other query from participants?
Sir,
Yes, yes,
hello.
ma'am. Yes, ma'am.
Sir, good evening, sir.
Yes,
Sir,
good evening,
very
ma'am.
simple question I have. In image classification, sir, which
Yes.
model I should use and which one I should use pre-trained model also?
For image classification, ma'am, you can start with ResNet or AlexNet. Okay, if you want to train your own images, if you want to go for fine tuning, in that case, what you can do?
ResNet
Yes,
50.
ResNet and AlexNet you can use.
ResNet and AlexNet. Okay, but should I use pre-trained model also?
Yes, ma'am. These are pre-trained models. ResNet, AlexNet, these are pre-trained models. And if we want our own data, then we go for fine tuning. Actually, what is difference in fine tuning and transfer learning? In case of fine tuning, we unfreeze all layers, unfreezing all layers, and then we retrain. In transfer learning, we change only 2 to 3 layers, last 2 layers or top 2 layers, and then we go for predictions.
Oh. Okay, sir. Thank you.
Any other query from participants? And if you have any suggestion, you can message any suggestion, any point of discussion. You are open and
सर जो आपने पीपीटी दी है वो खुल तो गई है, जो आपने गूगल वो दिया है उसको ओपन कैसे करेंगे? डाउनलोड हो गई है, ओपन कैसे करेंगे सर?
You can download it. So is it visible? Is it visible, ma'am? Is this visible? You can see
सर
that
वो डाउनलोडेड में तो डाउनलोडेड में दिखा रहा है.
हाँ जी. In download file, and after that you can directly open it.
ओके, अभी तो डाउनलोडेड में दिखा रहा, ओपन नहीं हो रहा है पर.
So, madam, this is a zip file, so you need to unzip.
Okay.
If you need direct PDF file, then rather than clicking on download files, you can click on this more individual file. Okay, in that case it will be in PDF. Okay, download file. If I want to download this file independently, more download file. Okay, then independently this file will be downloaded. Any other query from participants? You can.
Sir, is there any platform to master in OpenCV? Hello.
Hello. Yes.
Sir, is there
On
any
open,
platform? Yes, sir.
yes, on CV documentation, you will go for it. Okay, so you can see that this one I'm resharing my screen. I'm showing you.
Okay, sir.
Okay, OpenCV documentation. So you can directly search for OpenCV documentation, docs.opencv.org, and here you will get everything. Okay, what you want to do? You want to work with machine learning. You want to work with deep learning in OpenCV. All APIs are available. All scripts are available, and its documentation, detailed documentation is available.
Thank you so much, sir. It was very informative and new things I can able to learn out of this session. Thank you.
Thank you, ma'am. Any other query from participants? If you have any query, you can ask. Session is open for your queries, and after that, we will conclude this session.
Hello.
Yes, please.
Sir, good evening. Is it plausible to share the meeting link through mail also, sir?
Actually, that particular content will be shared via coordinator. So, from coordinating team, you can discuss.
We are posting in WhatsApp only. Sometimes WhatsApp has some problems, sir. So you can share both WhatsApp and email, sir.
Okay, sir. I will send an email and WhatsApp also.
Actually, because of this WhatsApp, some issues, sometimes it is not open.
Okay, so I will send in mail also.
Okay. Thank you.
Okay, so if there is no more queries, then should we conclude this session? Kindly confirm.
So what is the future of AI, sir? It's a general question. It is like more related to ML, DL, computer vision. So what would be the future according to you, sir, as you are an
As
industry
far as
expert?
future is concerned, you can integrate with large language model, and actually it is already implemented. Stable Diffusion, and so many other platforms are available. They are making use of generative AI. So integration of computer vision with generative AI with large language models, creating your own RAG. There is one concept that is known as model context protocol. Okay, retrieval augmented generation. So what we can do, we can create our own chatbot, we can create our own AI based application. Okay, on platform that will be able to identify the images, that will be able to take decisions automatically depending upon that specific image or object.
Using RAG, sir, we can implement this.
Yes, RAG and MCP, Model Context Protocol. These are related to generative AI, large language models. So if you are doing research in this domain, then you can link it with RAG. Okay, but to work with RAG, we have to be comfortable with Pinecone. Okay, in next session, I will show how to work in Pinecone, how to work on Milvus, and how to deploy it on web browser, how to deploy it on as a web-based application.
Okay. Thank you, sir.
Thank you.
Sir, I have one last query.
Yes, ma'am. Yes,
Sir,
ma'am,
is it possible to get your contact details so that we can connect with you after the session gets over also?
Yes, ma'am. In presentation, I have shared my contact mail ID is given. So if you are facing some issue, you are stuck at a particular point, you can mail me, and I will be happy to assist you. I will try to troubleshoot and
Okay.
you can contact, no issue.
Okay.
My mail ID is given, and if you are working on some particular concept, so try to integrate the recent technologies. If you are doing research, actually every teacher is a researcher, every professor is a researcher. So we have to take care of recent technologies. We have to adopt latest technologies at the back end. Generally, you might have seen, if you are already working with computer vision, with deep learning, machine learning, generally we use Excel sheet, CSV file, or text file, JSON file, XML file. Nowadays, we are working on vector databases. Okay, so we have to migrate to latest technologies. Okay, rather than classical features in Excel sheet, classical features in CSV file. Okay, those days are gone. So, and obviously, as a teacher, as an academician, many times we struggle for good publication. So, good publication will be okay. Good publication will be successful only if we will adopt latest technologies. Okay. So, integration of computer vision with RAG, then submit your paper. Definitely, so there will be more chances. Okay, we are not saying that it will be sure shot, but chances will be there for good publication in Web of Science, Scopus, or SCI.
Okay. Thank you, sir. Thank
you.
I have a question. So will the result be consistent? Like, for example, you have shown an example where you have taken five fingerprints, and then 3 of them were loop based or something like that. So if I run it again and again, will it be always this 3, or it may come to at some point? Because 2 of them looks more like loop, like to our eye. So I have that question. Will it be consistent or not? Like, suppose it is cat and dog. If one image is given cat as 70% and image dog as say 30%, but again, if I run that, will it be same or it will be different?
No, it will be same. Actually,
it will be always
yes, it will be consistent. There is no issue in consistency or integrity.
Okay, sir. Thank you. And another question, sir. Like,
and as far as actually these platforms are in beta stage. You might have seen lots of platforms are in beta stage, in initial stage. So in that case, so that's why we are saying that it is a matter of research. Till these platforms become too mature with so many publications, before that you can hit and trial. You can go for different permutation and combination, and only then we will be having good publications, good research projects. Are you understanding what I mean to say?
Yes, sir. Yes, sir. Thank you, sir. So another thing, like you said,
yes, please.
Yes, sir. Like we have used a pre-trained model, but can we do our optimize? Like, can we train that model with our data set? That is, that maybe.
Yes, definitely anything you can update. Any number of images, any type of
the
data.
One that you have done, the one that you have shown us, that was just you are directly using the pre-trained model without training your data. Your data set, right?
Yes.
So if we want to do, say, suppose
we can.
Yes,
if I want to give my own data, that can also be done. If we want to fine tune, if we want to, retrain it. Okay, so that code also I'm sharing. Should I share that particular code also?
Yes, sir. That part also we would like to learn, and I would like to learn means that where I can do my part also, like I can train it, and it will be still, it won't be too many codes, no, because I'm already, or it will be like developing from scratch, or it will be.
Yes, I'm showing you. Is it visible, ma'am? Is this visible? This
yes,
notebook? Sir. In this, some scripts I have generated. So I will show you first of all, and then I will share this notebook to all of you in same link. After some time, you will be able to refresh. So this is pre-trained model without any fine tuning. Is this visible, ma'am? ImageNet with G60. This is without fine tuning. Now I want to fine tune it. This is without fine tuning. Now I have some images. This is the folder cat this one, two images, dogs. So what I will do, I will upload to that particular folder in zip format. Once it is uploaded, then we can go for prediction. So full retrain. What is fine tuning? Full retraining. In full retraining, what we are doing, we are unfreezing all layers. Unfreezing all layers. Where
Okay, sir.
it is given, so you can see that unfreezing everything. Fine tuning full. Okay, so this notebook also I am sharing you so that you can experiment something. Just a minute. On same link I will upload.
Yes, sir. Thank you so much.
Full retraining and transfer learning. So this is full retraining and this one is transfer learning with your own data set. Okay, simply upload your zip file and go for its prediction. Just a minute.
Thank you so
I'm
much.
uploading on the same link. First of all, I'm checking where is that link that I have shown you. In this one. On same file bin link, I will upload on new file bin link I am uploading because previous link is not opening now. Is it audible and visible to all of you?
Yes, sir. Yes, sir.
Is this audible and visible to all participants?
Yes, sir.
Yes, sir.
So meanwhile, can I ask you one question, sir, if you permit me?
Am I audible
Hello?
to all? Am I audible to all? Kindly confirm.
Yeah,
Is
yeah.
it audible to all?
Yes, yes, sir. Yes. Yes, sir.
Yes. Network issue. So, okay, I'm uploading that fine tuning and transfer learning part. Now, dear participants, kindly confirm, is it downloadable or not? Scan this QR code again. This is a new QR code. This one, new QR I am generating. Just a minute. Kindly confirm, is it scannable or not? Simply scan this QR to download this notebook, Google Notebook, Collab Notebook, and is it downloadable? Is this notebook downloadable with transfer learning and fine tuning, retraining with your own data? In this code, every instruction is given how to upload a directory and how to predict. Is it downloadable? Kindly confirm.
Sir, can you give this link in chat box?
Yes. Link also I'm giving, and you can see that this QR as well as link, both I have given this QR code as well as link, and kindly confirm is it downloadable or not. Is this opening, sir? Gautam, sir?
Yes, sir. Yes, sir. This is downloading.
Okay. And other participants, is it downloading? Kindly confirm.
Yes, sir, it is downloading.
Okay. So if you have any query, you can ask. After that, we will conclude this
Sir,
session.
if you permit me, I'll ask one simple question,
Yes.
sir.
Yes, please.
So what is your opinion if someone wants to switch their career from teaching to industry? Suppose if someone wants to work on computer vision, because technology is every day updating. So can a teacher can switch their career into computer vision, sir, as a
Yes,
fresher?
definitely, ma'am. You can go for that. In that case, your programming skills related to Python, related to OpenCV, these should be very good. And along with, and not only with computer vision, you should be able to work with IoT-based programming also. Because in industries, in corporate world, multidisciplinary research is going on. Whosoever is working on computer vision, they are not only working only on computer vision, because whatever application, whatever device is having webcam or CCTV, it is linked with satellite. It is associated with wireless technology. You might have seen in matches, cricket matches, football matches, computer vision based robotic dogs are available. Okay, these are deployed, but these are not arbitrary. These are not independent. They are connected to satellite. They are connected to base station. So when interconnection is there, we need some wireless programming. So if you are comfortable in these, then you can definitely go for that. And obviously, as far as corporate world is concerned, industry is concerned, there will be more opportunities. Okay, so it depends on self-interest, whether you are interested more in teaching academic tasks or industrial applications.
Okay, sir. So for we need to practice projects also. We need to work on latest projects also, no, sir, to excel in this.
Yes, definitely, because when you will try for industry, if you will try for corporate world, they will see your assignment, they will see your portfolio. Okay, how many projects you have done so far, which type of implementations you have done. So you have to showcase your research work. You have to showcase your implementations. Okay, so try to integrate Raspberry Pi, Arduino board, some sensors, and then definitely you will be able to migrate to industrial ventures.
Okay, sir. Thank you very much, sir. It is really informative session.
Thank you, ma'am. Any other query?
So I think there
Very
is
good
no
evening,
more.
sir. There is one question only I want to ask, if you permit me.
Yes, ma'am, please, sure.
Yeah, thank you so much, sir. This is Dr. Bharti Kaude from Pune, Maharashtra. Whatever sessions, previous session as well as this session, both were very insightful and informative. I'm requesting for the PPTs and the contents related to these Python DL related codes. My question is regarding, can you suggest what kind of agencies who could provide the fundings, research project fundings? Surely we can get in terms of certain projects related to machine learning, AI, IoT, and all these together, so that there are more chances of getting the fundings from the research for the research project.
Okay. So, ma'am, in corporate as well as government sectors, both, there are multiple agencies, multiple enterprises. So, MIT is one of that. I think many participants here might have applied their MIT. Okay, earlier DST was associated with giving research fundings. If you want to work with corporate applications, with industrial applications, then many companies, many IT companies or interdisciplinary research-based companies give fundings. Microsoft is also associated with that. So what you can do, what is the best method? Okay, rather than naming 3 to 4 companies or 3 to 4 organizations, what you can do, you can download a web scraper. Okay, in ChatGPT also scraping is available. Python script, or with Python also we can go for scraping. What we can achieve with scraping? In a scraper, you can give a particular condition, you can give a particular query wherever certain research funding related to your domain is available, whether within India or outside. That particular notification you will get on your mobile number, on your WhatsApp or your email, because every day so many companies are coming to picture for research fundings. On LinkedIn also you can search. Okay. So, but major thing is that we should know how to fetch data. So data fetching means scraping. So with Google AI Studio, with ChatGPT, you can create a scraper. So many scrapers available. Okay. So those scrapers will find your responses corresponding to your query from throughout the world. And after that, you will get notification. For example, 20-30 notifications you are getting, and then you can select, okay, here you can apply. Are you getting what I mean to say?
Yes, sir. Yes, sir.
Okay, so some scraper you can adopt, and that is the best approach. Otherwise, 3 to 4 companies, 3 to 4 government sectors, government agencies we know, and these are not sufficient, if I say very clearly, because if you will apply for MIT, if you will apply for AICTE, DST, we don't know whether we will get funding or not. Okay, because so many things associated, so many parameters analyzed.
Yes, definitely. Yeah.
So many parameters are analyzed in those fundings. So rather than focusing on 2 to 3 agencies, simply scrape entire world, scrape entire World Wide Web, and get the notifications. Then select which is best. Okay.
Yes, sir, definitely.
20-30 agencies, 2 to 3 definitely will respond to you, and they will give you very good amount. They will fund very good monetary values.
Yes. Thank you so much, sir, for your suggestion and valuable inputs. Thank you.
Thank you, ma'am.
Good evening, sir.
Yes, good evening, sir.
Sir, actually, I belongs to mechanical background, sir.
Okay, sir.
But I am interested to vision-based this driver behavior analysis, sir.
Okay, fine.
So that's why I joined this workshop, sir.
Okay, sir.
So
in this, I think you might be working on drowsiness detection or sleep detection, something like that.
Yes, sir. Yes, sir. Yes, sir.
Okay. Actually, lots of work is going on in this particular domain. However, it is very difficult because as a research project, it is very good. For research funding, it is very good. But in realistic implementations, you can understand how much it is implementable, how many people will be able to adopt it. So if we are proposing such type of research project, then in that case try to associate with some government agency, and that government agency which is associated with law enforcement, so that whatever proposal you are giving, it should be applied in government sector, it should be applied in RTO. Okay, otherwise so many research projects are buried in files. Okay, thousands, lakhs or research projects are applied, research fundings are given, so many research papers are published, but these are under files. We don't know how many are implemented in real world. So but if you will try, if you will give some project, if you will give some proposal in association with some government agency, whether it is a transport agency, because if you are working on some drowsiness detection or some behavior detection, because nowadays so many accidents are going on every day, we are coming across news with so many accidents, and obviously as an academician, as a researcher, we should contribute, we should give some solution to these problems, and solution not only in form of a research paper, solution not only in form of only article, solution that should be applied by government agencies. So try to associate, try to apply to some particular agency in association with that corresponding department, with that respective department, so that they should apply. For example, you are proposing some drone application, some defense application, so try to associate Ministry of Defense, Ministry of Transport, Ministry of Education, whatever corresponding department is associated, so that those ministers, those policy makers should come to know that this is the policy, this is the solution, and we can adopt. And definitely it will be a social contribution, it will be contribution to nation, it will be contribution to country. Okay, rather than only publication.
Yes, sir. My question is how this computer vision we can apply, sir. Like now LLMs are coming.
Yes, actually, as far as implementation is concerned, you can start with open source boards, open source devices like Raspberry Pi. Very small projects you can propose. Like, because in Raspberry Pi, in Arduino board, we can integrate webcam, and once webcam is in, for example, we are proposing some device that should be integrated with every truck, that should be integrated with every driver seat, in front of every driver seat, in which there will be a webcam. That particular webcam will see what this person is doing, whether this driver is eating something, that is drinking something, or doing something, or taking some nap, micro nap. So that object detection, real-time video analytics, so such type of projects, and matching with some pre-trained model. Okay, if that particular person is taking a nap or eating or consuming something, then it should be matched with some object in large language model or pre-trained model. Okay, so something like that you can propose, and you can show some mini demonstrations. If you are working in some organization, you are teaching some students, so you can take a group of students, group of good students, you can ask them to develop such projects, mini projects, minor projects, or major projects, and those projects you can apply in form of a patent. Okay, patent, once it is granted, then you can move ahead for corporate application, for corporate deployment or government deployment. But first of all, we should start from scratch. We should start from mini projects, very minor projects, so that we can understand. First of all, our idea should be clear. What we want to do, whether driver detection, driver face detection, because so many complications are also there in this. For example, you are developing some, you have developed some device or some software for object detection, for face detection, for drowsiness detection, for somebody's emotion detection, then some person can say that my face is always like this. Okay, my face features are always like this. That I have consumed something. So because so many things available, so we have to take care of this part also, because it is one of the major challenge. In emotion detection also, many people says that my face is a sad face, I am serious person all time. So we can't say that this person is depressed, this person is under depression. Okay, because so many challenges are there in these things. Still, it is a matter of research.
Sir, Gaurav sir.
Yes, sir, please.
So actually, time is already crossed, so
Yes,
we
sir.
can conclude the session.
Yes, sir. Sure, sir.
Okay, thank you, sir, for your nice deliberation, and thank you all participants. So tomorrow again we will meet at 6 p.m. So thank you all. Okay, sir. Thank you, Gaurav sir.
Thanks to all participants.
Thank you, sir. Thank you.